Docker is an important open source platform for building, deploying, and managing containerized applications. Docker simplifies the delivery of distributed applications and have become increasingly popular. Similarly, Kubernetes provides an easier way to scale up your application compared to virtual machines. It keeps code operational and speeds up the delivery process. Kubernetes API allows automating a lot of resource management and provisioning tests and much more. We will begin this full course video with what Docker is, then we will look into the services and components of Docker in detail. Next, we will see what Docker container is and what are the basic commands of a Docker container. Then, we will focus on Docker Swarm and Docker Compose. After that, we will discuss everything about Docker networking. Then, we will see how to install Docker on Ubuntu and Windows 10. Next, we will talk about 12 crucial Docker interview questions and answers for beginners and experienced candidates. Finally, we will conclude this video by discussing the differences between the two famous tools, which are Docker and Kubernetes. By the end of this video, I can assure you that all your Docker query related queries will have been answered. Let's dive deep and learn about these important tools of DevOps. So, without further ado, let's get started.
Hello, this is Matthew from Simplilearn, and today we're going to cover what is Docker and why it should be of value to you as somebody who works in DevOps. So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same as the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and codebase, we use tools like Git and Gira. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the dockerfile. And then once you've created that Docker file, you'll store that image in the Docker Hub or registries. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker Registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be bear in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into two distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the two different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software or one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed, and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable, directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes. And it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you would experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network, so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from the CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about two key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way.
Today I'll be taking you through the installation process for Docker. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I'll just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, So before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now, as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install Docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state.
Welcome everyone to our another demo on which we are going to see that how exactly we can do the installation of Docker on the Windows platform, specifically on Windows 10. Now Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands we can do the installation, but in the case of Windows you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows 10 particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory, to the downloads, and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on OK. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the
execution of the installer to be completed. And once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part. Now let's start with what exactly is in DevOps all about here. Now DevOps is nothing but a collaboration between the development and the operations teams over here, which enables continuous delivery of the applications and services to the end user. So it's a combination or collaboration between the two teams, development and operations, which helps us to go for a further implementation of various processes like continuous integration, continuous deployment, continuous delivery. All these things are possible with this collaboration over here. Now, why exactly Docker is important for us as such? In a city far away from this one, so a developer decided to develop a tons of software on a single VM. Now he can put up applications. He is having a big server and he wants to host the multiple applications on a single machine. But for him, the virtual machine got a crash, because definitely if you are putting up more different applications as such on a single VM, it's not able to take up that much kind of load over there. So in order to avoid this situation, how exactly he can do the various options, or what he can implement to have this issue resolved. So ultimately Docker is something which is the solution of him. So if he really wants to host multiple applications on a single virtual machine, or he want to have different applications, then Docker is the ultimate solution for him to do that. And by doing so, there will be no issues as such when we talk about that the errors or the virtual machines cannot be crashed, and there will be no impact on the virtual machine as such. So why exactly Docker is important? So let's talk about the comparison between the Docker and virtual machine. There are very few reasons why exactly the Docker is being chosen over a virtual machine, because virtual machine is a full-fledged component which can take up any kind of load. But some of the reasons are still that in which case we will be preferring the Docker instead of the virtual machine here. The very first one is the memory uses. So Docker is having a very less memory uses because there is no concept of guest operating system, whereas on the other hand the virtual machines are going to take a huge amount of RAM resources in order to keep that particular operating system up and running. Second one, performance, because if you have less utilization and the users is less, the performance will be better. But for some reason, if you are taking up more resources, and you will not be able to deliver that amount of performance as such over there. And then again we have portability. So portability is also quite easy when we talk about the virtual machines. In case of Docker, it's quite portable as compared to the virtual machine. And then the last time is that the boot up time. So virtual machine boot up time is probably in minutes, but in case of Docker it's in seconds. So if we summarize it on this one, so the memory utilization, the boot up time, the performance, everything is better in case of Docker as compared to the virtual machines, right? For a classic example, let's say that what about the memory user? 9 GB of memory is something. If you can see that app1, app2 and app3 is there. So green and red color represents the occupied memory and the wasted memory. Now there is a particular utilization of, let's say that a server which is available there, and 3 GB of RAM is something which is wasted, and 4 GB of RAM is something which is being occupied there. So app 2 is using like 2 GB, and then you can see that the specific 2 GB of RAM is occupied and 3 GB is occupied, and the wasted one is 1 GB. So VM can see over there that 9 GB of RAM is used, and the remaining 6 GB of unused RAM cannot be reused here, because if, for example, I allocate like 4 GB of RAM to the virtual machine, it's there itself, it gets logged on. So it's not like, okay, I'm using only 4 GB RAM out of this 9 GB of RAM, then the next 5 GB of RAM will be totally wasted, so you cannot reuse it for any purpose. So this is a problem with the virtual machine, that if you allocate some memory to the specific virtual machine, if you are not using that much resources or that much memory, the remaining memory will be simply wasted, because this is hardcorely allocated to the virtual machine and you cannot utilize this unused memory as such over there. So this is the limitation from the memory perspective. But in case of Docker, definitely if out of the 9 GB of RAM, if we are using only 3 GB of RAM, so whatever the unused memory is there, so we can actually reuse it for the new containers. So it's not dedicatedly allocated to the virtual machines. If you are using out of 9 GB, if you are using 1 GB, 2 GB, 3 GB or 4 GB, whatever the remaining memory is available, that you can simply use it for the other containers also. This ensures that you always go for an optimal utilization of your resources, and unnecessarily there is no wastage of the different resources or the different components over here in this one. So that's the reason why the Docker containers are quite efficient in terms of memory when we compare it with the virtual machine. Next one is the performance. Now in a virtual machine, we know that on the infrastructure, on the physical infrastructure, on top of that you put up a kind of operating system, a base operating system is there, and then on top of that you have the hypervisor, and this hypervisor then is used to create the virtual machines, which is having a kind of guest operating system inside it. Now the issue over here is that you have two operating systems over here. So the guest operating system is also going to take some particular resources, and for example memory or a space, a processor. So in every resource terms, it is going to go ahead and say that okay, I'm going to use the particular some of the resources. Now problem is that if you're hosting a very small application, you will end up in having a more consumption, because of this guest operating system will take more of the resources, and then you are just using some very small resources for your application in a real world. So Docker container on the other hand does not have a concept of the guest operating system, and that's where what happens, that the Docker engine is more than sufficient to handle the Docker containers, and inside the Docker containers there is the application which is being hosted over there. Now with this one, definitely the performance is quite better as compared to any virtual machine, because of the terms that there is no unnecessarily wastage of the resources. Because in the previous case, virtual machines, a full-fledged guest operating system is up and running, you need some resources to be allocated to that, but in case of containers, you don't need to have that particular functionality implemented. Then portability. So having a portability or moving an application which works on a system A does not mean that it will work on the system B also. This is a similar problem which we face, that usually the application works perfectly fine in a lower environment, and when it goes to the production environment, it sometimes fails and it does not comes up properly. So this is an portability issue which we have when we talk about the virtual machines. But when in case of containers, when we got a container up and running in a lower environment, and once the container is prepared, you don't have to do the changes or modification to that depending on the environment. The same container can be deployed to production environment, and it's very easy. So whatever container prepared in the lower environment in a dev environment, the same will work in production environment without any issues, because it contains all the dependencies and executables, everything inside it. So you don't have to do any kind of modifications or changes to these containers as such over here. And the last one is the boot up time. So the boot up time of the virtual machines is in minutes, and whereas the boot up time of the Docker containers is in seconds or probably in milliseconds. So these are the reason why we consider the virtual machine as an resources based environment. But on the other hand, Docker is something which is quite light, and fast as compared to virtual machines. So let's see that what exactly is in Docker all about here. So in this one, you can see we have the physical infrastructure on which we have the host operating system. Now we don't have the hypervisor and the guest operating system. Instead of that, we have the Docker engine, which is taking care of managing the Docker containers. And inside these Docker containers, you have the applications and all the required binaries and the libraries here. So there is no concept of the guest operating system. This Docker engine is the person or is the process which is taking care of all the requests which is going on, and if this Docker engine is up and running, then all the containers will also be accessible and will be available. Now Docker is nothing but a OS level virtualization software platform that enables developers and IT administrators to create, deploy and run applications in a Docker container with all its dependencies. So Docker is a very important tool nowadays if you want to look forward to host your application, because of its portability benefit that you don't require much of the changes depending on the platform or depending on the environment. So whatever the developers are able to build up, the same thing will go till the production environment. Now let's talk about what exactly is in Docker container here. Now Docker container is a lightweight software package that includes all the dependencies, whether it's a base operating system, some framework, some libraries. It's something which is a part of this one, so that if you will be if you want to host your application, you will be able to do that. So it's a complete package. So both the source code and the dependencies is what you put up inside the Docker containers. Now within these Docker containers, you can have multiple applications there, multiple programming languages, multiple frameworks can be hosted there. In fact, the databases also can be hosted within these Docker containers. You can host them as such over there. Now, what are the different advantages of Docker? Let's talk about that. Now, the first one is the rapid deployment. So, rapid deployment is the very first advantages which we are getting over here. Second, quick and easy configuration, better efficiency, portability, scalability, and security over here. Now there are different ways in which we can understand the benefits, or we can have the understanding about the Docker here. So these are some couple of benefits. Now let's take them one by one. The first one is the deployment part. So it supports the rapid deployment. Now just like a web application, for instance, I want to deploy to website, so there are some couple of steps which needs to be done across different environments. Like for example, if I have 5 environments, I have to do the deployment, the same steps in all the 5 environments at the different period of time. Now when we talk about Docker containers, we don't have to run those steps multiple times, because once those steps are executed in one Docker container, the same Docker container goes till the production environment. So you don't have to actually do a rebuild of the Docker containers, and you can simply say that, okay, I have got the Docker container here, so you can just run one or two couple of commands and that will help you to host your Docker containers. So you don't have to redo or rework on any kind of the deployment work into the production environment or into the higher environments. And then we goes for the quick and easy configurations. So the configurations of Docker containers is quite easy. You can have your own custom Docker images built out the Docker files. So these processes can be integrated within the Jenkins also. So CI/CD is quite possible with the help of Docker if you want to really do that. And then we have better efficiency. Yes, they have a better efficiency and resources management as compared to the virtual machines. Portability, we have already talked about that it's easy to move from one environment, from one system to another. In fact, it's easy from the developer also. So from one machine, from one developer to another developer, it's very easy to move these different Docker containers. Then we have scalability. Scalability is also possible with these Docker containers. Just like multiple virtual machines, you can also create multiple containers and you can share the traffic out of that. So, but that scalability and all is possible with the orchestration tools. Then security is there, so you can have your best practices of the security implemented, because it's just a kind of a virtualization, just like a virtual machine. So you have all the different possibilities which is available, which you can explore when you want to make these Docker containers secure, right? So these were some of the benefits which was there for the Docker here. Now let's talk about the installation of Docker here. Now, installation of Docker is pretty common, and whatever platform you want, it's available over there. So it's available for Ubuntu, Windows. It's available for Mac operating system. So for Ubuntu, you have to run the commands on the Ubuntu operating system to download it. And for Windows, it's actually having a particular exe file, so you can go for the installation of exe file. And then we have the Mac operating system. So for Mac operating system, you have the DMG files, and when you do the DMG file, so it will help you to install the component over there. So Mac, you can also use the homebrew once to do the installation of that particular component. Now next one is the architecture of Docker. Now the architecture of Docker is pretty straightforward. There are key components which is available there in the architecture of Docker here. The very first one is as the client facing is the Docker client. Now Docker client, or you can say the Docker CLI, is available there. Now this is the component, it's a command line interface which takes up the request from the end user. Like for example, I'm running the command, so it will take all the requests from me as an end user, and it will send those particular things or the requirements to the Docker daemon, to the server, using the REST API interface. So this Docker daemon is something which keeps on running on the server, and it's a background process. It gets deployed as a service there. In case this Docker daemon is not available or it's not up and running, you will not get the proper response from the Docker command line here. So in order to get your activity or your procedures implemented, you need to have the Docker server or Docker daemon up and running. In fact, this Docker CLI can be configured to connect to any other servers or any other different server Docker daemon also. So it's a connectivity which is happening over the REST API interface, where all the requests are processed, are sent to the Docker daemon, and whatever response is coming back, that is given back to the end user. So what are the different components of Docker here? Let's talk about that. So Docker client consists of the CLI component, like we have already discussed. So that is something which is going to take up all the requests from the end user. Then it's using the REST API interface, which is there to have the connectivity with the Docker daemon. So Docker daemon is something which is always up and running. So if you run couple of commands like docker pull, push, and also that activity, you are actually sending the request to the Docker daemon, and Docker daemon is actually doing all the work. So it's not a Docker client which is doing it, just taking, it's kind of an interface which will take the things up and send it back or send it forward to the Docker day. Right, so it's a background process which keeps on running on the server, on the operating system, and it's the same process across all the infrastructure, all the different platforms, whether you use Mac operating system, you use Windows, or you use Linux. Everywhere this is the basic functionality, and it keeps on listening to the REST API interface. So whatever the new request comes in, it immediately processes it, and whatever the response, whether you are stopping a container, whether you are running a container, according to that the action will be taken, and the response will be sent back to the REST API to the Docker client. So a Docker is a process, or it's a command line which is used to start the Docker daemon. When you run the command like service docker status on the server, you will be able to see the command which is getting executed in the backend. So there you can see that Docker is the process, or is the command line which is used to initialize the Docker daemon. And of course there is a kind of configurations which you have to pass it on as parameters. So even if you run ps-ef command, you will be able to know that what process is running from the Docker perspective. And the third component is a particular Docker registry. So we have a ready-made cloud service which is available, known as the Docker Hub. So you can actually store the Docker images on these Docker registry. So there are a lot of ready-made Docker images which is available there, but of course you can have your own Docker image also over there, or you can have your own custom registry, Docker registries also. For example, in JFrog, you can have your private hosted registries also. So all these different repositories you can use with your Docker containers. So Docker containers is having the flexibility that whichever registries or repositories you want to connect or you want to establish the connectivity, you can always do that. Now let's talk about the Docker image over here in detail. Now a Docker image is nothing but a template of instructions. It's having a couple of instructions in which you will be using these instructions to create a final Docker container. So Docker image is nothing but, for example, I want to have a Tomcat Apache Docker image. So what are the instructions I have to do? So the very first thing is that I have to pick up a base operating system. Then on top of that, I will be installing the JDK or some prerequisite packages. And then on top of that, we will be configuring onto the Tomcat Apache there. So these are the steps. These are the different instructions, step-by-step procedure, which we are implementing so that at the end of the activity, we will be able to have a Docker container ready, which we can deploy to host Tomcat Apache. So it's a template which is having all the particular instructions. In order to build a Docker image, you require a file called dockerfile, which is of course having all these different instructions embedded in that. So when you run the Dockerfile, it acts like a build tool. So whatever the instructions you are putting up over there, all those instructions are getting processed and you are able to get an end result. Then these Docker images are actually comprised of multiple layers. So multiple layers are available there. So step by step. So you will be first of all having a base layer from which the image starts. On top of that, another layer. For example, you did the installation of JDK. So another layer will be there. And then you did the configuration of the Tomcat Apache, and then another layer will be there. So it's a multi-layered component which is available. And these layers are in incremental order. So definitely the oldest one will be known as the base layer, and then on top of that all the latest changes will be done in the latest layers there. So this is an example. Now here you can see that there are 4 instructions, and these 4 instructions are also known as the 4-layered Docker image. So whatever the final Docker image you will get, in there you will be able to see 4 layers of the Docker image here. Now the very first is Ubuntu. So Ubuntu 18.04 we are pulling up, and then we are pulling like the file over here, and then we are running the make utility, and once that is done, then we are running that file.python file over here in this one. So these are 4 instructions which is available, right? So which will definitely help us to do that, how exactly we can make or we can perform the different activities right from the base. So in this case, the base layer will be like the Ubuntu one. So Ubuntu one will be the base image, and the moment the final CMD attribute or CMD attributions are processed and executed, after that you will be able to get a final full-fledged Docker image over there. So this will be a full complete Docker image or Docker container which you will get once the whole build process is completed. Now in this ways you have you can see that the previous Docker file which we processed, so the base layer is Ubuntu 18.04. we are not building that, actually it's automatically it's by default getting downloaded as a full base layer. After that only we have like layer 1, layer 2, layer 3 added up, because those modifications we are doing it after the because from does not means that you are doing any kind of layer modifications. It's just like you are importing some base operating system or base image. So the modification or adding up the layers is only done after the base layer there. So whenever a user creates a container, a new layer is something which is stored on top of the image. These layers are known as the containers layers. So Ubuntu one, the very first instruction does not comprises it. It's not a kind of container layer. We can call it as an base image layer there. So every container has a separate read-write container layer, and any modification in a container is reflected upon the container layers only. So layer 1 may be having some different of instructions, layer 2 may be having different instructions. So like that is a step-by-step processor. In case whenever a container is deleted, the top layer also gets deleted over there in that one. So if I delete some particular containers, and that is something which is gone, so it was suppose having like 3 layers, so the top layer will be simply deleted because the container is also deleted for that particular part. Now Docker uses a copy on write strategy with both Docker images and Docker containers. So whenever we perform any activity, or whenever copy on write strategies and strategy to share and copy files for better efficiency. So it's something which is being used to increase the overall performance of the Docker containers. It also makes Docker efficient by reducing the uses of disk space, because whenever required, okay, whenever is needed, only at that moment of time it's actually performing the copy, and it definitely reduces the overall disk utilization. And this is very important also, because when you have so many Docker containers up and running, so you have to worry, or you have to make the utilization of a disk, or your disk uses or resources also minimum. So that is also, you need to make sure that it does not exceed a particular value. So once the utilization is also less, then definitely the overall performance will also be better and improved over here in this case. So let's talk about some of the facts here. So the base layers are something which is purely read-only format, so you cannot do the modifications. Union file system saves the memory by avoiding the duplications of the files. The layers can be combined in a union file system to create a single image. So all these layers are combined and got a final product, or called a, you can call it as Docker image or Docker containers. And this allows a file system to appear as a writable. So now let's talk about the Docker registry. Very important component, because even if you prepare the Docker image locally and you don't have the collaborative tool, or you don't have the tool where you can share these images, definitely it's not easy for you to port these Docker images from one system to another. So Docker registry is very important for the portability feature of Docker. So Docker registry is a service to host and distribute Docker images among users. So it can be built up by one user and multiple users can use it. For example, I'm using a Jenkins one. So Jenkins image is prepared only once, but it's being used by different people as such. Docker registry, again, it's a repository, is a collection of Docker images. So in a repository, you will be having like different Docker images as such. So in registry, a user can distinguish between the Docker images with their tag names. So for example, Jenkins is a kind of a single image. There might be different type of images there. Let's say that, okay, let's talk about Jenkins JDK8. So there will be an image called Jenkins. The name of the image will be same, but the tags will be different. So one tag could be like JDK8, one tag would be like JDK9, and one tag would be JDK10. So the difference between all these three Docker images is that JDK8 one is prepared on JDK8, it's running on JDK8, and if you want to use JDK9, in that case you have to pull down the Docker image of Jenkins with the JDK9 installed. So depending on the frameworks, or depending on the runtimes, so with these tags, different tags are processed, so you can have the distinguish between the Docker images, and whichever Docker image you feel you want to use, you can implement according to your requirement. And Docker by default is having its own cloud-based registry called as Docker Hub, which gets automatically connected when the moment you do the Docker installation. But in case you are working into your private infrastructure, so in that case you may use the repositories, Docker repositories on the specific JFrog Artifactory, or the private repositories also can be hosted. But Docker Hub is something which is having a public and private repositories both. So you can create either the public and private repositories. You can use push and pull activities to interact with these Docker images. If you want to download a Docker image, so you can run pull. If you want to push your Docker image to the Docker registry, in that case you can run the push activity. So in both the cases you are doing the interaction with the Docker Hub. So when you run some build process, or when you run the containers, there may be some Docker containers which is getting pulled down from the specific registry from the Docker Hub, and if that specific image and tag is available, definitely pull command will be successful. But in case of push command, you are pushing your custom Docker images. You cannot push the ready-made Docker images which is available. You can publish your own Docker image only to the Docker Hub, and then you can further on do the pull and push activity accordingly to those repositories. So whatever the ready-made and third-party images which is available, you can only do the pull activities to them. You cannot do the push activities. Push command scenario will only come when you are interacting with your custom Docker image. Next one is the Docker container. Now, Docker container is an executable package of an application and its dependencies together. So when we prepare a Docker container, we actually combine both the dependencies and the application source code inside it. So the Docker container don't have to look for the dependencies on the host machine on the server. So this is one of the benefit where we see that the portability is very easy, because whatever I'm building up on one system, everything is inside the Docker container, so I don't really need to do any further activity on other machines. So whatever works on one system can be easily worked on another system. So it's very lightweight also, so it can be easily deployed and executed on on their particular servers, because it does not take that much utilization like a virtual machine. So if you are looking forward for having your application hosted into your local system, you can easily do it within the Docker container. So the utilization is very less as compared to the virtual machine, so you don't have to worry about your host operating system and the configurations. So Docker containers can run in totally isolation, just like a virtual machine. So there is no interaction, or there is no interference. So they share the OS called kernel, but the thing is they don't have the interface as such over there. So it works totally in isolation. Two different containers will not have any interaction unless and until we set up that the containers to have the interactions. Now there is data volumes which can be shared and be used among the multiple containers. So you have the capability over here that if there is some unused space that can be easily shared across the multiple containers here. So it is built using the Docker images. So using the Docker images, the Docker containers are built up, and Docker run is a specific command which is used to build a Docker container. So if you got a Docker image, let's say that I have prepared a Docker image, a custom Docker image using the dockerfile. Now if I need to create a Docker container out of a Docker image, I have to run a Docker run command. So Docker run command is nothing but it initializes or creates an instance of a Docker image. Now next component is the Docker Compose. Now typically when we work with the Docker containers, so we had to run, like if I want to run like 5-6 containers, I have to initialize like 5-6 times, or I have to run Docker run commands 5-6 times there. So and if you want to create a relationship between the containers, then definitely that is something which you need to manage using the Docker commands. But sometimes it's not an easy task for you to run those commands manually or remember those commands. So Docker Compose is a utility over here using which you can actually run multiple containers with a single service. You just got a kind of a single file, you just run it, and all the containers, definitions and relationships, everything is inside this Docker file here. So you want to run 2 containers, that's totally fine. Instead of running 2 commands, now you just have to run 1 file, and that will take care of that. Now you may be having more than 2 containers, 5, 6, 7, whatever number of containers you have, that can be easily deployed without any manual activity or without any maintenance onto the server. So these containers totally run in isolation, but yes, you can establish the interaction, that how they want to interact with each other, and that interaction you can put up in these Docker Compose file. So Docker Compose file is something which is written in a YAML format, and in this you define that okay, I need 2 containers, and this in this image should be there. These are the parameters which you need to run, and if you want to have the interaction or the linkage between the images, that also you can establish within this YAML files, or within this Docker Compose file here, right? So let's say, for example, I want to have an application which requires Apache web server and MySQL database. Now I can create a Docker Compose file which can run both containers, and without you don't require to restart or start them separately or initialize them separately. So I will be having a final Docker Compose file which is having like containers like Apache containers and MySQL containers, both inside a single Docker Compose file here. So that's the benefit you are going to get, because now you don't have to run them separately, separate Apache and separate YAML MySQL. So you can get it done with the help of a single Docker Compose file here. Now what exactly is the Docker Swarm? Now Docker Swarm is a inbuilt, or it's a default orchestration tool which is being provided by the Docker itself. It's a service for containers, which allows the IT administrators and the developers to create and manage a cluster of Swarm nodes. So in a typical world, when you do the installation of Docker, there is a limitation that some of the features like high availability, multiple instances, or scalability, all these things are not possible as it is with the core Docker. Now on top of that, you require the orchestration tools like Docker Swarm, where you have a swarm of node machines, 5-6 node machines are there, on which you can have your highly available application infrastructure implemented. Now this one means that if I want to run my applications 5 containers, 6 containers and 7 containers, for that purpose we are using the Docker Swarm. So each node of Docker Swarm is having a Docker daemon, which is used for performing the interaction. So there will be a master node which is available. So it will be interacting with all the node machine on all the client machines, and this interaction will be in such a way that it will let them know, okay, I want to deploy the container or onto the node 3, so it will perform that activity and the container will be up and running on the node 3 there. So a swarm consists of 2 type of nodes. One is the manager node and one is the worker node. So manager is the master node which you can refer, and the worker node is the one which is actually doing most of the work. So the manager node is not something which is expected to host anything apart from the main component, but yes, you can always configure if you feel that you want to only deploy the container on the worker node. So that also you can do during the deployment of the containers. So manager will keep on connecting to the different worker nodes there, and whenever new request comes in, so it will basically try to connect and see that, okay, I just want to go ahead and deploy a container. So it will do the deployment of the container on the worker node. So the main work will be done by the worker nodes, and manager is just doing the management of all these resources. The worker nodes will be definitely receiving the request from the manager, and it will be proceeding and performing those activities. And if for some reason worker node is not active or online, so the master node will not be able to deploy the containers on that server. So right now let's talk about a demo in which we have to create a Docker image using a Dockerfile on the Ubuntu 20. So we want to use a base operating system as an Ubuntu 20 there, and using that we are going to create a custom Docker image. So let's connect to our virtual machine and see that how we can do that. Okay, so as part of this demo here, we are going to prepare a Docker image, and in that we are going to use a base image of Ubuntu. So let's take an operating system of Ubuntu 20. 20 is the latest version of the Ubuntu operating system. So I have got a server, so let's see. So first of all, we have to install the docker.io package, which will install the Docker package, and then we can enable the service. We can make sure that the Docker service is up and running, because if the service itself is down, then we will not be able to perform any activity. And then a sample, if you run docker run hello-world, so that is going to pull a Docker image from the Docker hub, and a particular activity will be done to you. So once that is done, so we can say that, okay, the container is up and running and everything is got over there up and running. And then you can also try some of the Ubuntu Docker image also. If you feel that you want to try, you can do that. But the main demo which we need to do over here is that we need to prepare a custom Docker image, and in this one we will be having we will be using an Ubuntu base operating system. On top of that, we will be installing PHP, Nginx, all these different components. So we are going to have a PHP based website hosted onto the Apache web server as an Nginx, and then we will be able to access that application. So the very first thing which we need to do is that we need to create a folder. Let's say that I just create a particular folder called Nginx-image, and then I create a Docker file over there. So Docker file content we are going to take from this one. So let's go to the server and see that how we can go ahead with the activity. Now what we can do is that we have got a server over here. Now in this server, what I'm going to do is that I'm going to proceed with the installation of Docker first. Now when I do the Docker installation first, so what will happen, that I will be able to have my Docker installation completed, and then further on I can take the further steps of having the accessibility of going through the understanding that what is this particular platform, or how to prepare different kind of containers. So I have got a particular container over here. So what I can really do is that I can simply say that, okay, I have got a server. So this is a Ubuntu server, so I'm going to run the command called app update first. Now this will do the update locally, so all the links and everything will be updated. Now the whole idea about doing the updates is that so that I will be able to have establish the fact that I'm trying to connect to the Ubuntu URL, so that at any moment of time I should be able to fetch on the latest packages. Now once that is done, so I'm going to run the command called apt install docker.io. Now the moment I do this, what will happen that it will try to download some packages. It will ask for the confirmation. You can give your confirmation and I can say yes. The moment you give the confirmations, the download of the packages will proceed over here. Step by step it will download the packages and the installation will go on. Now once the installation is done, so what you can do is that you can see that Docker is deployed into your system or not. You can run docker version command, or you can also use the service command to check, to make sure, to ensure that the Docker service is always up and running. If the service is not up and running, you have to make sure, you have to enable it, you have to start that service. So these are some couple of steps which you need to do in order to make sure that your connectivity or your environment is ready with the Docker installation. And once the Docker installation is done, then only you will be able to proceed further with the further activities like preparing the containers, preparing the images and all that stuff. But if you don't have the Docker installed prior to that, then definitely it's going to be a problem. So just make sure that before even doing any kind of activity, before even doing any kind of steps, we ensure that the Docker is fully up and running. So it's going to take some time to download the packages, and we will wait for that. And once the installation is done, we will continue further on that part. Okay, now once the installation is done, so you can run the command called service docker status, and when you do that, it will let you know that whether the Docker service is available there or not. So you can start the service in case you don't get the proper response, and now you can see that it's showing up that a process is running. So earlier it was not up and running, it was inactive, but now it's active. And you can see here that dockride is the process which is running over here as a process to initialize the Docker daemon. So Docker daemon is up and running now, and we are good to go here. So now if we go and say like docker run hello -world, so we are doing a validation to our Docker instance that whether our Docker instance is working fine as expected or not, because if there is any kind of problem with the Docker daemon and Docker daemon is not up and running properly, we would be able to get an error message over there. But right now there is no error message, which represents that yes, you are pretty much running the Docker image and it's giving you the proper response. So you will be able to see the Docker images when you run. So you will be able to see that the Docker image is pulled down to your system, and definitely you have executed that and it got you the response. Now the next thing which we need to do is that we need to run a particular Ubuntu one. So for example, if I go for docker run -it Ubuntu bash. So what exactly we are doing in this one is that we are pulling down a Ubuntu Docker image and we are running the bash executable on top of that. The whole purpose of doing that activity is that so that if I want to do some process or I want to perform some activity, I should be able to connect to that Docker image. So the moment I do this, first of all, if this Docker image is available locally, that's great. It will immediately create the container. If the Docker image is not available locally, the very first thing which it will perform over here is to pull down the Docker image, the correct one. And as you can see here that it definitely pulls down a Docker image, and once it is done, so it got a terminal for you. Now you can see it shows that root at the ID, root at the rate 1 ID is there. This ID is nothing but it's a container ID which we are getting here. So definitely you are inside the Docker container, and when you run the Docker, when you run the exit command, you will see that you have come out of the Docker container over here. And the moment you run docker ps-a command, you can actually see also that how many container you deployed so far. So you ran hello world, you ran the Ubuntu one, both of them are stopped there. You can see the exit 0 in the status over here, because both of them are something which you ran in the interactive mode, so they are down. So if you want to keep your container up and running, you need to have a container which runs in the dash mode and always up and running. But for that, you have to go ahead to the level where we need to create a custom Docker image, and do the setup accordingly. So let's see that how we can do that. Now I'm going to create a particular folder called nginx-image. You can pretty much give any name, whatever name you feel you want to perform, you can do that. Now in this one, I'm going to put up a file called dockerfile. So let's see that what content we need to put as such when we talk about the dockerfile, because whatever content you put over here, that is what according which the Docker image will be prepared. Now here we have to talk about, so first we have to see a base image. So we are saying that okay, Ubuntu 20.04 is what I want to use. Then we are giving some labels. Now these labels are used to give some information like what is the version, who is the maintainer, what is the description. You can do the customizations to this one. So these labels are actually defined and utilized so that I will be able to give an information that okay, so and so developer is something which we can contact. So if there is any kind of problem with the Docker file or with this build script, we have to reach out to that specific person. So this is what we typically do with the labels here. Now we also have to set up a parameter like Debian_frontend as in non-interactive, because whenever we talk about any build process in Docker file, it cannot be there in the interactive session. It should be there in the non-interactive. And definitely a typical scenarios like you can run app update command, and then we are installing the PHP, Nginx, Supervisor, all these things we are doing the installation. We are using the run attribute, run a particular step, and in there whatever the commands are executed, these statements will be executed when we will be doing the build process. And then we are using some environment variables. Okay, so nginx virtual host, php_conf, nginx_conf, and supervisor_conf. These are the different environment variables which we configuring over here. Now next thing which we have is that we have to transfer some files like probably nginx and the virtual host file. We may have to transfer from a Linux server to the destination to the Docker container. So for that we are going to run some copy commands, copy statements, so that we can do that stuff. And then definitely we are transferring the supervisor configuration file also to the server, so that we can have that configurations set up over there. And these supervisor_conf and all these different variables we have already established, where we are saying that what exactly configuration we are looking forward over here. And then we are creating some folder structure. Where www.html folder structure we are creating, so that we will be able to push some content over there. And then we have the volume configurations. So whatever the volume configurations are there, we are putting up, so that we will be able to have all the specific directories mounted on the host machine, on the host server, so that we can even talk about locally also. And then the star.sh is something which we need to run, because that's that will go into the command statement which needs to be executed. Because when you want to run your process, when you want to run your nginx process or your Docker container, some process should be up and running. That's where if any interactive process will run, then only the Docker container will be hold up. So that's what you can do or you can configure over there. So I'm going to copy this whole content. Now this whole content represents the complete Docker file. So we have already gone through this content one by one, but if we combine all these content together till the expose part, that's where we come up into these one. So expose, we are doing 80 and 443 over here, right? After this one, we have to create the host file, virtual host file, supervisor d file, and the star.sh file. So let's go back to the server here. Now in this one, you have to you can use whatever editor you feel you want to use, you can do that. So this is what my master file will look like. You can see I'm running some run commands. These are the environment variables I'm using. Then further on, these variables I'm using just to define the paths. Okay, so you can see that this default file we are copying from the host machine, from the server to the Docker container. And then second file is supervisor d.conf file, and then we have star.sh file. So these are the different files which we want to configure here. So once this file is prepared, we have to type in, or we have to create a default file over here in this current directory. So in this current directory, we have to put up a file called default. Now in this one, we will be having the default virtual host configuration config. So we need to put a server attribute saying that we have to look forward for index.html or index.php and these kind of files from the var www.html directory there. So I'm just going to copy this content and put it up into this one. So this is how my final file look like. So I'll save it. And then we have a supervisor d.conf file. So I'll just copy the content of this one. I'll copy it, and we have to create a file called supervisor d.conf file. Now names we can double check because we are referring these names into a Docker file, so we can double check that. So once this is done, save it, and we can check the Docker file. We can grab, so you can see, okay, this one, so supervisor D, so the name is correct, that's cool. So we got a default, we got supervisor D. Now we have to create the start.sh file, because in this one we will be configuring that how we want to start our process of this Nginx or this web server. So in this one, again, we have to run the supervisor D process over here and a configuration file. So we are going to put this one, and we'll go here and put this content. Right, so we got the supervised config also available, so that's also there. And the moment it is done, so you are going to give the execute permission to this one, because you can see that into our Docker file that we are having the attribute where we want to run this into the slash there. So if you want to refer in that mode, you have to change the permissions, and case so that change mode, you have to give the execute permission to the start.sh here. Now once this is done, so what you got is that you got a particular components, like you got some couple of commands. You have got Docker file, supervisor.conf default, all these files are there. Now the only thing which we need to do next is that we need to do the build process. So if we look forward for the build process, so what happens, the docker build is the command which we need to use, and nginx-image is the name which you want to refer. Now you can totally use this custom name, whatever name you feel that you want to use, you can always use that. There's no restriction on that part. And once that is on, so you will be able to list down those images that you got a new custom Docker image here. So you can see that you got the Ubuntu as a base image which is built down, and the nginx-image is also prepared over there. And once that is done, so you are going to create a web root folder, and you can run the docker run command to see that if you really got connected with that particular one. So let's go back and see that how we can create the Docker custom Docker image here. So the moment I do this, so it will pick up the Docker file over here and start performing the activities. The package installations, all those configurations ones will be performed over here in a non-interactive mode. There is no confirmation which will be asked from the user, because you cannot put that confirmations. So the command should be in such a way that it should not take any kind of confirmations at all from the end user. So because tomorrow you may be putting up these things in the Jenkins, so that will not be a feasible thing for you to put up the commands and put up the confirmations during the execution. So it's trying to do the package installations for the PHP. So FPM packages are getting installed, and here we go. So we got the successful message. Now you can see it says successfully tagged this one. This means that there is no issues at all with the Docker image, and when you run the Docker images or Docker images ls, you can run these couple of commands. So when you do that, you got a 237 MB of the size of this image. That represents that this Docker image is fully ready to run to execute. So now what we are going to do is that we are going to map a volume over here with the var www.html directory during the execution of this container, because I really want to deploy some pages, some web pages there. If you have the web pages now as part of the build process, as part of the Docker file, you can do a git clone also of some repository, but I don't want to do that during the preparation of Docker image. I just now got an environment where the Nginx is set up properly and it's up and running there. Now it should be upon me that how I want want to put up my content and all. So that's the reason why I'm putting up a kind of a folder structure over here and sharing it with the Docker container, so that the moment I put that the HTML files or the PHP files into that local folder, I should be able to get some web page up and running there. So that's what I'm going to do over here in this one. So I'm going to create a folder structure saying / web root here. Okay, so there is a folder structure which is created. Now in this web root, I will be putting up some files, and then same files will be redirected inside the Docker container with the help of Docker volume. So let's go back to the document. Now here you have to run once, like I said, that you are going to connect on that part. Okay, so you can use this port as an 80 also, but here 8080 is used, so whatever port you feel you want to use, you can do that. And we are giving the container name as test and -container. That also you can change. And nginx-image is the one which we are using, so if you use some different particular image, you can also use that. And you can see that the web root is something which we are connecting with the var www.html directory. So the moment you put some file in the web root, the same file will be reflected into the var www.html directory there. So I'm going to run this command, and once this is done, so you can see that for the testing purpose we are putting up some content in the HTML one. So I'll come to that point also and we'll validate. As of now, we should be having our container up and running over here in this one. Now I'm going to copy that command, okay, and hit on. So if the 80 port is used, so you have to make sure that port gets gets stopped automatically, or it should not be up and running. So just double check whatever port you are using, that should be free. Now when you run the docker ps command, so you will be able to see a Docker container up and running. But if you see like docker ps-a, that gives also the stopped and running, both the containers are there. But the main thing which we want to run is that we want to run the docker ps command, and you can see that this is a container which is running. So 8080 is the container which is running, and test-container is the name. Now you got a container up and running, so you can actually do a curl on localhost colon 8080. So this is a way to get the content. You can get the public IP also, and in the browser you can put up and you can have the content there. But right now we are getting the response. At least it's showing as 403 error, forbidden error, but that's fine. We will be putting up some web pages there in the var www.html directory, or we can say in local web root directory, so that we will be able to have some content. So what we can do is that we can have some echo commands executed, so that we can have some content added up into the particular files there. So let's see that what different contents we can do. So you can use the vi mode also to do a couple of files. So I'm just using this echo command. So the moment I go for this execution, so what happens that a file will be created into that /web root there. So I'm expecting that I have put up a index.html page. So if you feel that you want to put some different page, you can always do. And the moment you do the curl, now you will be able to see the same response. So whatever the things you put up in the index.html file, the same content is going to pop up when you run the curl command. Now you want to use some PHP files, you want to put up some PHP content, all that stuff you can do it. Now what I'm going to do is that rather than just HTML static content, I'm going to put some PHP content that is going to help me to get a file. So my web root will have now 2 files. So if you feel that index.html file should have some meaningful content, you can always do that. You can pull some of the websites also. You can put that into the, you can do a git clone in the web root, and the whole application will be started. And now if you feel that I got a info.php file, so I can use that name into the URL. I have to modify the URL because index.html file is the what as in default name page you do. If you want to put up some different name, you can change the server configuration of Nginx, and according to that it will work. So when I do this, so you will start getting the output. So this is the PHP content output which is there. It's a complete information. Now it may look like a very bulky content to you, but when you put up this one into the browser, into the web browser, that will be a meaningful information, probably in terms of some tables or something like that, right? So let me scroll to the top here. So you can see that it's showing an error, it's showing in the output, and this output represents that you got a particular PHP content here. So this is how we will be able to have a container, and this container is up and running. You can modify to at any level you feel that you want to prepare a Docker image with the code embedded. Also, you can have the git clone, or you can have this configuration into some git repository, have the source code also there, and then prepare a complete bundle altogether. So this is what we have in this demo, how we can deploy a container and a container up and running in case of the Docker here. So that was the demo, right? Which we took to create a custom Docker image on using the Dockerfile on Ubuntu 20.
Let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then typically, in your traditional environment, then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software, but probably doesn't have all the development software. And certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called Learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it name my. So this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment. And we'll put in the image name, which is Ubuntu. And -bin -bash. And it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state. It's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container.
Did you know, before Docker and containers were introduced, companies had been deploying their software either on a bare metal or in a virtual machine. But they had been facing a lot of challenges in managing orchestration of services, instant deployment of services on different platforms, and maintaining multi-host applications. All these issues were solved with the help of Docker and its containers. In this Docker and container tutorial session, we will give you the conceptual exposure to Docker and its containers. Consider an example where a company develops a code on Oracle WebLogic software. In the company, a developer installs Oracle WebLogic software on his computer system. Once the application is developed, he shares it with the other team for testing the code. Now, the tester repeats the WebLogic installation process which was done by the developer earlier on his system. Later, the same application file is shared with the production team. To host the application, the system admin must install Oracle WebLogic on his system. Let me ask you an important question here. Have you noticed that the same WebLogic installation process was done thrice? But what could be the reason behind it? Due to the difference in computer environments, WebLogic doesn't work on the other systems, so installation is done separately on 3 different computers. But this process of installing the same software on different systems consumes a lot of time and effort. In order to avoid these problems, Docker containers were introduced. Before we start with the concept of Docker containers, let me explain you what a Docker is. Docker is an open source platform that helps a user package an application and its dependencies into a Docker container to develop and deploy software. Docker provides suitable frameworks for different applications. Since every application has a framework with an appropriate version, this space also can be utilized for a new software application along with its required framework. As a result, Docker makes more efficient use of system resources. Containerization includes all dependencies, frameworks, libraries, etc. required to run an application in an efficient and bug-free manner. With Docker containers, applications can work efficiently in different computer environments. After this, let's talk about the benefits. The benefits of Docker containers show up in many places. Containers are widely used because of their services. Since it's lightweight, it can be easily deployed and executed on other computer environments regardless of their host operating system or configurations. Containers take up less disk space and relatively faster in executing applications. Containers run applications in isolation and also share the operating system kernel with other containers. By default, containers are entirely secure. Container policies ensure all applications are highly secure, including the Docker infrastructure. Containers are highly portable and can run anywhere across the Docker ecosystem. Multiple software can be encapsulated in a single container and can be easily deployed to different platforms. As soon as a container is created, it can be deployed into any other system where Docker is already installed. On that system, the application will perform exactly as it did in the previous environment. Containers take less boot up time. These containers save time in the deployment process of an application. Here comes the next important concept, virtualization. Virtualization is the technology of running a virtual instance of a computer system or running a virtual version of a computer resource like hardware, software, storage devices, and computer network resources on the cloud. A virtual machine is an isolated computing environment that allows developers to use an operating system via a PC or computer system. Let's now talk about some of the significant benefits of using Docker containers. The first benefit is the lack of external dependency. Containers have no external dependency for applications to run. Containers will just be used to host and run the applications. As containers are lightweight, they are quickly shipped to other computers and executed in different computer environments regardless of their host operating systems. Containers are lightweight. They share a kernel across containers and therefore use less memory space. The next benefit is the volume. Volumes are also a convenient way to share data within the Docker ecosystem. Volumes can be more safely shared among other containers. And the last one is isolation. Containers run application in isolation and share the operating system kernel with other containers. In containers, the host operating system provides isolation. Along with the applications, microservices can also be more easily isolated. Next comes the most important topic of the session, that is containerization versus virtualization. Containerization and virtualization are two different ways to deploy applications and microservices in a computer environment. In VMs, a hypervisor is a firmware layer that enables multiple operating systems to run side by side. A virtual machine has unstable performance as multiple running VMs run simultaneously on the same machine. Also, the efficiency of hypervisors is not as good as that of the host operating system. Due to the extra layer in VM, an application takes quite a long time to start. As you can see, there are two architectures on the screen. On the left hand side is VM and on the right hand side is the Docker. On the left hand side, as you see, there is one host operating system, a hypervisor, and guest operating system shared by all containers along with their dependencies. In VM, guest operating system occupies more space and leads to unstable performance. Guest operating system makes virtual machines less efficient than the physical machines. Guest operating system makes a VM slow because they access the hardware indirectly. On the other hand, Docker is efficient. Unlike VMs, Docker doesn't have a hypervisor or guest operating system. Docker consists of containers. These containers are efficient and are easily portable across different platforms. In VMs, the hypervisor has a scalability issue. The hypervisor creates a security risk as well. Well, did you know that according to Vitana, the chances of experiencing a data breach while using virtualization are high? Well, that could lead to a major problem for companies who are still using virtual machines. Next, let's have a closer look at the Docker containers. In case you are unsure what kind of applications can be added to a container, then look on the right hand side. A container can package Apache Tomcat and its dependency, that is Java programming language, in a single file. Later, a user can ship the container to another computer environment and run the code without any issue. It's usually challenging to understand the differences between container and VM. So, let me explain to you the differences in layman terms. As shown, the virtual machine is compared to a bungalow and the container is considered as an apartment. In a bungalow, amenities like water, lift, roof, etc. cannot be shared with the neighbors. Likewise, VM is less efficient. It doesn't share its resources with other applications. On the other hand, containers share their amenities, binaries and libraries with the neighboring containers, just like a person who resides in an apartment. The bungalow is owned by a single person. It cannot have tenants. Likewise, Virtual machines cannot run multiple applications. On the other side, Docker runs multiple containers just like numerous tenants reside in a single building. Next, let's look at the table in which we have made a direct comparison between virtual machines and containers. In Docker containers, data volumes can be shared and reused among multiple containers. Either Docker CLI or Docker API manages the volumes. Also, the volume drivers give the facility of storing volumes on remote hosts or cloud providers. VM is a container-based model. It utilizes user space along with the kernel space of an operating system. So, data volumes cannot be shared. Containers have a better performance as they are hosted in a single Docker engine. Docker provides the most substantial default isolation capabilities among the other configuration tools, making the performance better. Virtual machines run multiple VMs at a time, which leads to unstable performance. Docker is much more efficient than hypervisors. Docker enables developers to wrap, ship quickly, and run applications as a lightweight and portable container. On the other hand, virtual machines are less efficient. Docker containers can run multiple containers on a system, but virtual machine can run only a limited number of VMs on a system. Multiple software can be encapsulated in a single container and can be easily deployed to different platforms. Containers are easily portable across other platforms, but virtual machines have compatibility issues while porting others across different platforms. Moving on to the next one. Let's have a look at the architecture of Docker. A Docker or Docker engine consists of two major components, Docker client and Docker daemon. These two components are connected to each other with the help of the REST API. Now, let's take a look at the architecture. A Docker client has no components, but a Docker daemon consists of a Docker host, Docker daemon, Docker registry, and Docker images. Docker client is a service that uses REST API to send commands to Docker daemon through CLI commands. REST API is a primary mode of communication between Docker client and Docker daemon. Docker engine or Docker is a client-server application that builds and executes containers using Docker components. Docker daemon checks the client's request and communicates with the Docker components to perform a service. Docker engine or Docker is a client-server application that builds and executes containers using Docker components. Docker image is also one of the essential components of Docker. A Docker image is a file of instructions that are used to create containers. A Docker image is built using a file called dockerfile. A Docker image is a template of instructions that is used to create containers. Coming to containers. A Docker container is a portable executable package that includes applications and their dependencies. Docker containers are lightweight because they do not require an extra layer of a hypervisor and run directly on the host operating system. There is a service in Docker called Docker Compose. A Docker Compose is used for running multiple containers as a single service. In Compose service, each container runs in isolation but can interact with each other with no limitations. Talking about Docker Registry, it is a service used for hosting and distributing Docker images among users. Docker Registry is a service to host and distribute Docker images among users. Let's move on and understand how to create a Docker container. First, ensure to set up your development environment. Then, you can begin to develop containerized applications. For that, you need to create a Docker image. A Docker image can be created using a dockerfile. A Docker image is created using a build command. You must build a Docker image that contains the code of what your application needs to run. In simple terms, a Docker image contains all the project's code. With Docker image, you can run the code to develop Docker containers. Once the Docker image is created, ensure to store it in the Docker registry using the docker push command. Once a Docker image is created, you can either store it in a Docker hub or in a repository. Docker also has its default registry called Docker Hub. There are multiple Docker images available in the registry and all can be retrieved through the docker pull command. As soon as a Docker image is retrieved from the Docker registry, you can build new containers. Moving on to the next one, let's understand how Docker containers work. In Docker, a Dockerfile is used to build the image using the build command, and that image is stored in the registry using the push command. When you run the pull command, Docker image is retrieved from the registry, while a single container is built using Docker image through the run command. Did you know that a new layer is formed on top of the Docker image layers called the container layer when a container is created? This new layer consists of the application and its dependencies. In Docker, each container has a separate read-or-write container layer. Any modifications done in a Docker container are reflected upon the container layer. Suppose a container is deleted, the container layer also gets permanently deleted. This was the simple functionality of Docker and containers.
In this one, we are going to see that how we can make use of the Docker files to prepare a Docker image, and using which we can create a Docker container. Now let's talk about what exactly is in Dockerfile here. Now Dockerfile is a concept which is being used as a build script. So it's being used so that we can have a build script there. So this will definitely helps to see that how we can go for a build of a Docker image, a custom Docker image. Now when we are using the Dockerfile concept, so it really helps to prepare a kind of Docker image. So Docker image is the end result when you are going for the mechanism, when you're going for the Dockerfile build up here. So Dockerfile is a build script which is available for preparing the custom Docker containers, because not every Docker image is available on Docker Hub. So some containers you have to use, some images you have to use to work on that part. Now Dockerfile is a very simple, straightforward text file which is available there, and it's basically used to build up custom Docker images. So Dockerfile is basically used to prepare so when you're running the Docker build, so it's actually going to build up a particular custom Docker image, and that will be given to you. So Docker image is the whole build process which is being done. So it's a custom process which is available and being done over here in this case. So you got a Docker file, you run the Docker build command, and that's how you will be able to get a Docker image. So whatever the steps you are having in the Docker file, that will be processed one by one, and as a end result you will be able to get a full-fledged Docker image over here in this case. Right, now let's talk about the syntax of the Docker file. So Docker file is equal to commands and the arguments. So whatever the things you want to put up, so in the Docker file you can do that, and as a part of the execution, so you will be able to get a particular end result. Now it's a kind of a mechanism where we feel that how the execution and the modifications can be done. So the comments which we are trying to do over here is that, you know, we can put up the whatever the comments we want to put in the case of Docker files, we can do that. Comments is a standard process in preparing any particular file or any kind of code, because it helps us to understand that for what reason we are preparing that particular line. Then we have the particular run statements. The commands are there, so you can see that we are running a particular command called echo. So using the run attribute, we are basically going ahead and running a particular command into our system as part of our Docker file over here. Now how to build up the Docker images using the Docker file. So you know, Docker file is just a template which is available there, where we are putting up that what are the different steps we want to follow, and these steps when we follow one by one, step by step, so that's where we will be able to get a particular final Docker container over here. So Docker image is getting converted as a Docker container, and we are getting a Docker container as an end result. Now Docker file is being built up and stored in the version control system, and this particular Docker files when we are processing, so it prepares a respective specific image layer over here, and this image layer is something which is benefiting us, that how the executions can be done and how we can manage on that part. So That really helps us to see that how the executions and the things can be managed, and that can help us to see that how the management of the things can be performed as such. So Dockerfile is a very good concept which is there, using which you can prepare any kind of custom Docker image, and it can be very easily handled also. And it's a fully automated mechanism. You can use it inside the CI/CD pipelines for automating the Docker images. Right now, it's Docker image is a layer by layer mechanism which is there, in which we have multiple layers. Each and every layer we are doing some specific entry, some specific task, or some changes we are trying to deploy in part of these layers. Right. So you can use the particular docker build command to perform the executions, and you will be able to get a particular response, and output will be given back to you. So Dockerfile is basically helping you to see that how the executions can be done, and you will be able to get an end result over here. So the Docker image is the final result which we are getting when we are talking about the Dockerfile here. Right, so these are all read-only formats which are available. You cannot modify these directly, but yes, with the help of Dockerfile you can do whatever the changes you want to deploy on these Docker images. Right, so this is a small example where we are using a base image as an Ubuntu 18.04. So we are using the from attribute to specify that yes, we are going to use the Ubuntu 18.04 here. Then we are pulling the file into the directory. We are transferring a particular file inside the Docker container, and then we are running a make command, and then cmd attribute is there, using which we can run the command on the runtime on the Docker container. So these are a very basic example, but eventually when we are done with this Docker image, we will be able to get a 4-layered Docker image over here, because there are 4 steps, and then hence it will be providing you a particular 4 layers in your final Docker image over here. So layer by layer these changes will be done during the build process, and in fact using the Docker history command you can see the layers, these layers information also. Right, so layer 1 is Ubuntu 18.04, layer 2 is pull, and the third layer is there where we can run the make command to run this file which we have pulled on, and then finally the last one is there where we are running like using the cmd parent. So the difference between run and cmd is that cmd will run only when you run a Docker container. So run attribute will be executed during the Docker build part. So this is pretty much is a way that how we can go for the execution of a Docker file, and how we can go for the build up of a custom Docker image over here. So these are the some couple of attributes which we are using in the Docker file here. Right, now let's talk about the entry point over here. Now entry point allows you to specify a command along with the parameters. Right, so let's say that you want to run a particular command over here in the Docker container. So entry point is something which you can use to refer to that. So application is the command which you're trying to run, and then you can give some arguments to that, and argument 1 is what you're trying to run over here. So entry point is very important, because that eventually helps to see that how the executions can be done, and the implementations will be done over here in this case. Right, so you can see like you can run a command called echo, and then you can use the parameters also. It's not like only the commands can be used, but you can in fact use the arguments also. Now add is an attribute which is available in the Docker file, which is primarily used to transfer the files from the host machine inside the Docker image. Now let's see that you are trying to prepare your own custom Docker image. Apart from the dependencies, you need the source code also, right? So the source code needs to be transferred inside the Docker image, and for that reason we can use the add attribute. So add attribute requires a source and destination. Source will always be the path on which on the host machine the files are present, so we can give that. And destination is the folder which is available inside the particular Docker container where we want to store the files. So you can use the example over here just like this. You can use, and you can give 2 entries. One is the source, one is the destination. And once that is done, so you will be able to see your files being stored up in the destination directory once the final Docker image is prepared. Then we have env attribute. Now env is something which is used to set up some environment variables. which is required, of course, for the Docker image, for the application which is running into the Docker image. Now, environment variables are something which you can hardcode during the Docker build one, but using when you are running, like when you're creating the Docker container, at that time also you can override these environment variables. So environment variables are very important because first, during the build process, you can hardcode some values, but if you really want to change them during the runtime, that also is being supported by the environment variables. So most of the times we use it as a kind of a key value pair, just like in Linux we use to set up a particular environment variable. So the key value pair is being used in case of env attribute. Maintainer is there, where we can describe that what is the details about the author. These are the fields which is available in the top, so where we can give the author name and the author details like email ID and all, so that we know that who is the person who is maintaining this particular file, and we can reach out to them in case any issues are there for the Docker file CM. Right, so that is what we have here in this one. So now we are going to see that how we can go for a small demo on Dockerfile, and we can go for the implementation of this particular Docker file and prepare a custom Docker image. So let's just wait on that part. So let's see some demo here. Now in this one we have got two examples. One is a Python, one is the Node.js one. So first of all, what we need to do is that we need to process the Python one here. So this is the sample Docker file which we have got here for the Python. Now all this one requires a Python file which is already present on the server, and we are going to transfer, we are going to copy this content over here. This is the specific Docker file content which is available to us, and all we need to do is that we need to put this content across the server so that we will be able to build our custom Docker image. So let's go back to the server. So here we have already got the Python file which is present. So we have to create a Docker file here which will have the steps related to the Docker image preparation over here. So we will be including some steps over here, that these are the different steps we want to configure, we want to set up over here in this one. So Python 3.6.4 is the version of the Python which we want to configure, and then we are going to transfer some files into /app. We are also setting up the working directory as /app, and ultimately we are running a command called pip install flask to do the installation of Flask package, and then we are starting the specific applications on that part. So I'm going to save this file, and once I save this file, so all we need to do is that we need to create a custom Docker image, right? So right now there is no image which is available over here, and it's a complete empty instance. So I'm going to run a command called docker build -t python -am dot. So docker build is the typical command, but -t is for the tag, that what kind of Docker image you want to build, and then we are giving a image name, and then we are specifying dot over there. Now once we are done with that, so it will pick up all the things one by one. The basic Docker image is being pulled down, then some sequence of steps is being executed. So it's a step-by-step process which is happening over here in this case, and we are then transferring some files in the /app, and then ultimately we are going for the pip install flask. So it's installing those packages, and at the end the final Docker image will be prepared and will be given back to us. So we will be able to get this Docker images over here. When we run that command, we will be able to find out that we got our custom Docker image also available. And as you can see that the base Docker image is also available in this one, but yes, we have added up like around 10 MB of work we have added on top of this Python base Docker image here. So that's how we are able to do the processing over here in this case, in this setup. So that's what we can do to prepare a custom environment of Python with the help of the Docker file here. Now let's see that we will be proceeding on with the Node.js to see that if the Node.js kind of setup also can be done. Now for Node.js, again, of course, we got the specific Docker file which is present, so we can process that. But let's create a new folder over there. So I'm going to create for a new Node.js folder so that we can create the work all together in this one. So I'm going to run a command called npm init, which is the command to initialize any empty project in case of Node. Now you can typically bring on some real code also, or you can say that I want to process an empty project. So you can give the configurations, you can give the custom names, but I want to process with these default name itself. So ultimately it's going to create an entries like you will be able to see like all these values which we are not providing. These standards value will be picked up for the specific code, and at the end you will be able to get a package.json file created over here in this one. Now you can actually bring down the steps that how you can perform, or you can build up a custom Node.js based Docker image. Now these Docker files is giving you the capability that you can convert a full-fledged application which is deployable on the virtual machine. You can actually convert them in the format of the Docker containers over here in this one. So that's what we are going to get over here with this particular setup or these mechanisms. So let's go back to the document and see that what exactly we can copy the Docker file. So we have got this Docker file over here. So all we can do is that we can copy this one. So once we copy this specific file here, so all we can do is that we can transfer these files into the onto the server. We can convert it into the Docker file there, so that we will be able to set up the configurations and we can perform the setup around that. So Docker file is again we want to create and we want to set up on that here. So let's go back to the server. So here we want to create a Docker file, and we want to set up the files inside that. These are the different files which is being available, which is being configured over here in this one. So we are running like node server.js, which is the master file. So we are doing an expose of 8080. Then of course we have copy commands which is there, then npm install command is there, and then package.json file is also there. Now what you need to really do is that you need to go for a server.js file which is available, in which you can configure that how the setup needs to be done and how the configurations should be performed there, because that's a command, that's a script which is going to be executed within the container. So let's copy the content. Now I'm going to copy this content over here, which is like a sample Node.js code which is available. So I'm just copy this one and transfer it to the server. So server.js file we have to create here, just like we did in case of the Python, because this is the source we want to transfer inside the Docker container. So this is what we have got. Now I'm going to transfer like a I want to change this port value from 5000 to 8080, because that's what it's configured in the Docker file. Of course you can configure 5000 also, depending on your requirement you can do that configurations. Now you have got these two files over here in this one. So all you need to do is that you need to run like docker build -t node.js -app and dot. So it will automatically pick up like what exactly it will go for the Node.js basic Docker image over here. So that will be processed over here in this one. So step by step it will be able to do the configurations. So first of all it will download the basic Docker image, which is quite more in size over here in this one. Once it's downloaded onto your system, then it will proceed further with the build activity on processing the Docker file, performing the execution. So all that stuff will be performed with this help of this Docker build process over here. So it's going to process it one by one in this one, and it's going to the next step where it's transferring some of the files, like creating some working directory, transferring the files, putting up there and running the npm install command, and then ultimately it will expose the port, and then it will have the cmd attribute configured over there. So this is basically typically trying to portray that how a particular Docker image can be built up. And of course once the build is success, you can validate it with the help of Docker images here. So this is the app Docker image which is being prepared of 911 MB, and we have got it like a final package where the runtime is also there and the code base is also available. Now you can pretty much experience it like with other actual source codes, like you can download some pre-configured Node.js websites or the source codes there, and you can try to run them onto the Docker container so that you can get the full the complete idea about that how it goes on. But right now these are the basic Docker image which you can prepare and you can build up over here in this one. So that's how it really works on for you.
Let's dig into what a Docker swarm is. So a Docker swarm is essentially a tool that allows you to very easily create and schedule multiple Docker nodes. So really 2 or more Docker nodes. And you can have quite a large number of Docker nodes in a single swarm. Each node itself is actually a Docker daemon, and that daemon is able to then interact with the Docker API and have all the benefits of being a full Docker environment. One of the other advantages you have is that each Docker container within the swarm can then be deployed and managed as a node in that entire clustered environment. So what we have here is a breakdown of the 5 key elements within a Docker environment. You have the Docker container, you have the daemon, the Docker images, and the Docker client and Docker registry. So the Docker daemon itself is what does all the work interacting with the actual host operating system to be able to manage the Docker containers. So if we look here we have set up an environment where we have 3 Docker containers being run with Docker. And what we want to be able to do is be able to interact with the environment, because what would happen if we actually have something change in our environment? So we have the environment set up as a Docker swarm and one of our containers fails. What we're able to do is use the swarm to be able to correct that failure. So the Docker Swarm Manager is able to come in and reschedule containers. And as you would imagine, the actual Swarm node has full backups and full redundancy for any kind of failures that would happen. And we would do all of this work through command line interface. So let's go through some of the features that you have within the actual Docker Swarm itself. So a key feature for Docker Swarm is that it is fully decentralized, which means that it makes it very easy for teams to be able to access and manage the environment. As you would expect as well, is that the communication that happens between the manager and client nodes within the swarm is highly secure. And of course, this is really just a fundamental that you should have for any kind of solution, but it is good to know that Docker Swarm has that built in. There is also auto load balancing within your environment, and you can actually script that into how you write out and structure your swarm environment. And that load balancing then also allows you to then convert that swarm environment into a highly scalable infrastructure. And then rollback task allows you to be able to roll back environments to previous safe environments. So if, say, something does get pushed out and something breaks, you're able to immediately roll back into a safe environment. So each of the containers are pushed out and are controlled using services, and they actually happen to be REST services, which make it very easy for you to be able to integrate within your environment. And each of the different services contains a group of containers of the same image. Now, by having this structure, it allows you to be able to scale your application appropriate to the demands on your service. So if you have a service that needs to have a significantly larger number of services for it to run, you can actually scale that appropriately, and that can be either geo or demand based. One of the requirements for setting up a Docker Swarm is you must have at least one node deployed. So the way that the architecture is set up is that you have a manager node and a client node, and there must be one of each for the entire environment to be able to work effectively. So, here we are, just jumping ahead of ourselves a little bit. We have 2 types of nodes in a Docker Swarm. We have the manager node, and we have the worker node, which is the client that does the actual execution of the tasks. The manager node, very similar to other systems that we've talked about on Simplilearn, allows you to actually control and manage the actual tasks that are being executed by the worker nodes. And the worker nodes, as you can imagine, then actually execute the instructions that the manager are sending out to it. So here we have a situation where we can illustrate what would happen with a manager node sending out commands to different worker nodes. The manager is fully aware of the status of the entire swarm environment at all times. This is because of the 2-way secure communication that's going from the manager to the worker environment. The workers, as you'd expect, are accepting tasks that are being sent from the manager. So if the manager sends out a task saying that you need to be running as a MySQL environment, then the worker node will then convert to a MySQL environment. And all of these environments are scripted and controlled by you as the manager. The actual worker nodes themselves actually have a client agent, and that client will then communicate all different states of the infrastructure back to the manager, so that any time the manager node is in full control of the entire swarm. The manager is the controller of this environment, and so you always want to be able to ensure that the manager has full access to all of the work that's happening within the swarm, and this allows you as the manager to be able to control your swarm and very quickly be able to react to any changes without having to rely on manual installations of software and hardware. And as we covered earlier on, there is a REST API that uses the communication over HTTP from the manager to the worker node. It's interesting to note that it is a REST API because if you wanted to, you could actually integrate that API into custom applications and even then create automated Docker images to be created on demand from third-party solutions that you may want to create. So one of the things that's a big advantage with having a swarm is that once you've actually created the swarm, any of the services that you create can be accessed by any node of the same cluster. One of the things you do have to do, though, is you have to specify what container image that you're going to use when you're creating a new service. And you can do that either through a centralized Docker Hub environment or through your own private Docker Hub environment. One of the things that's interesting is that you can set up commands and services to be either global or replicated. A global service will allow you to run a service consistently on every node within the swarm, whereas a replicated service will only push out functionality and tasks to specific worker nodes within a swarm. So you may be asking yourself, hey, isn't a service and task the same thing? No, they're kind of not in the Docker world. And the difference is a service is a description of a task for the state, whereas the actual task is the work that needs to get done. And that's the differentiator here. So what you can do as a Docker user is you actually create services, and then you can then define when you want them to start as tasks. Now, what's interesting is that when you do assign a task to a node, that same task cannot be assigned to another node. Also, what's interesting is that you can actually have multiple managers within a Docker Swarm environment. If you do, however, go down this path, you have to elect one manager to be the primary manager and the other managers to be secondary managers. In many ways, those secondary managers are really similar in concept to worker nodes in which they have the capability of a manager, but they are dependent on that single primary manager to be able to provide the right instructions and for services and tasks to the entire Swarm environment. So if we kind of recap some of these, we have a command line interface, which allows us to create and connect via APIs. And that those APIs that we connect to in our Swarm environment allows us to do orchestration via tasks and services. The task allocation allows us to allocate work to tasks via their IP address, which allows them to execute them on the work. And then the worker nodes themselves have to connect to the manager node to be able to check when tasks come in so that they are keeping a consistent communication back and forth across the entire swarm. And then the final stage is to actually execute the tasks that have been assigned from the manager node to the worker node so that you have a successful execution of the solution you're looking to build. All right, so with that said, let's go ahead and we're going to do a demo. So we're going to go ahead and do a demo and showing how you can run Docker Swarm. For this, you'll need to have both a virtual environment running your manager and your working environment. So here we have our worker and here we have our manager. So we're just going to open up terminal window and we're going to go into the manager for terminal window. So the following command here is used to initialize Docker Swarm. We're just going to type this in. So sudo docker swarm init. And we put the IP address for the network we're connecting to. And we'll put in our password. And here we have now connected. And this is our manager node. And what we want to be able to highlight is the specific token which identifies the Docker Swarm environment. And this is our token right here. So we're going to copy that because we'll need to use that for our worker environment. So here we are in the worker environment and we'll use the token that we just copied as a way to be able to connect to the manager and connect to the Docker Swarm environment. And so sudo, we'll paste in the Docker Swarm and we'll join that. And now here we shows that we have joined the Swarm environment as a worker. And now that we're in the manager, we can actually show that we actually have that worker in the environment. So there's docker node ls to list out all of the items in that environment. Sorry, we actually did that in the wrong area. So we're on the right, sudo docker node ls to list out all the nodes in the swarm. And there you are. You see we've actually connected the worker to the manager node, and both are active, and the manager is the leader and the worker VirtualBox is in the swarm. Okay, we're going to go ahead and create a new service. So Docker Swarm create, and we're going to just change the name to Hello World for the new service, and we're going to use the Alpine image from docker.com. Takes just a moment for it to run. There we go. And there we go. Services converged. So what we have now is a new service that has been created. Let's go ahead and we'll list out the services. And here we have our new Hello World service. And we go ahead and check the Docker containers, and we're going to do Docker PS, and here's our Alpine. It's running the latest image, and that's the Docker container ID. And we can see that it was just updated. And so what we're going to do is use the same command in the worker node and make sure everything is working over there. So go over to our worker, paste that in. So what we see here is there is no image or container created because it's not in the worker node. It would be in the manager node. So we can go ahead and create the new service. And we're going to make the mode global, and that way the service is available across all of the swarm. So we're just going to execute that work. Takes a moment. And there we are. Done. Work has been completed. And we have the two different IDs, which shows the two different services running. And if we go back to the worker mode, and we run sudo docker ps again, and there we are. Now we see that we have the Hello World new virtual environment has been added with the image of Alpine, and we also have the new token ID for that. If we want to kill a node from the swarm, we can use the following command, which is sudo docker swarm leave -- force, and that will force the node to leave the swarm.
One of the questions that will come up, though, is what if you want to use two containers in a single service? And an example of this might be like a web server that is using a database, but the database may be in one container and the web server may be in another container, which is very typical for your own web and database infrastructure. So very similar scenario, but how would you do this with Docker? So by using just Docker itself, it's actually very difficult to do this. You can do it, but it's just very time consuming and just not a very good use of your productivity. But with Docker Compose, you can actually do the whole process quite quickly and easily, and hence the reason why we have Docker Compose, to allow you to have two or more Docker containers running in the same environment, being able to communicate as if they were running in a production environment. So let's dig into what Docker Compose is. So let's consider a scenario that you'd have today. So Myntra is a fashion website similar to Amazon, and you would go to Myntra with your web browser, and on that website you would go through a number of activities such as logging into your account, browsing a catalog, you'd have your checkout application server, and you go through the typical process of building out an application. Behind each of these services are different products, such as you'd have an account database, you'd have a product database, different checkout processes, and these would all be run behind the scenes. And each of these can be considered a microservice. So the more microservices you build into your environment, the more complexity you're adding, and the more of value it would be to have each of these services in their own container. But as a developer, you want to be able to jump from one container to another container, so your login account can then be passed onto your product catalog and then be able to move through the whole process. So the environment that you would see today would be more like what we're showing right now, where you'd have your server and your database, and you may have a server running on Apache Tomcat or SQL Server. You'd have different databases, and you'd want to be able to have each of those in their own containerized environment. So the way that Docker Compose runs is that it works as a single service. So you have the Docker Compose running multiple containers, but the perception is of a single service running. The thing that's great, though, is that each of those containers will run in isolation, but they can interact with each other. So unlike a normal Docker environment where you have multiple Docker images running completely in isolation of each other, these are images that will run in isolation but can interact with each other. The Docker Compose files are very easy to write. They're all written with a scripting language called YAML, and YAML is an XML-based language. It actually stands for yet another markup language, but it's an XML-based language and it's very easy to use. The great thing about learning YAML is that a lot of open source tools in the DevOps environment use YAML as the scripting language. And then finally, in Docker Compose, as a user, you can actually go in and trigger all your services within the containers to start with a single command. As you can imagine, this dramatically reduces the amount of work that you as a developer have to do. So let's take an example of if you're running a container, one with a Nginx server and one with a Redis database. You can create a YAML Docker Compose file that actually has the instructions on the containers needed to build out both environments. And then you can run each of those environments separately, but have them connected as a single service. So the benefits of Docker Compose is that you have a single host deployment environment. You can run this all on one piece of hardware. You can have a quick and easy configuration using YAML scripts. The productivity that you get as a developer significantly increases because you're not having to have time wasted trying to configure just traditional Docker containers by themselves. You now have a way of being able to interact with those containers. And then finally, security is at the center of all of these containers. So each of those containers are completely isolated from each other, and they are controlled with the same level of security that you'd have with a traditional Docker image. But there is a question here around Docker Compose. Isn't it similar in concept to Docker Swarm? Because at a high level, it kind of seems like both do the same thing. And the answer is, well, actually, no, they're different. There are similarities, but there are also differences. And particularly for a developer, these differences will really start coming out in scale as you start working on your solutions. So let's look at Docker Compose. So Docker Compose will allow you to create multiple containers on a single host. And that's the important part, having a single host, which is maybe your development PC. With Docker Swarm, it also allows you to create multiple containers. However, you have to manage those multiple containers on multiple hosts, which makes a lot of sense if you're running an operations environment, but not so much if you're doing a development environment. And Docker Compose is scripted with YAML, which is very easy for you to be able to control your scripts. Docker Swarm doesn't have a scripting technology like YAML, so it's a little bit harder to work with. So what we have here is just some basic commands that allow you to get up and started working with Docker Compose. In our next demo, we're actually going to take you through how to use all of those commands. So we're going to go ahead and do a demo on how to use Docker Compose. The first thing you want to do is check that you have Docker installed. So what we're going to do is we're going to open up the command window and we're going to type in Docker. You'll be able to see now that we have Docker installed. If you don't have Docker installed, go ahead and install Docker. You can go to Google search to install Docker and they'll give you the instructions for that. We also have videos that we've already done. If once you have Docker installed, then you want to do a Google search on Docker Compose or go to the docker.com website and select for the Compose section and look for the install Docker Compose instructions. So we already have another tab which has the the instructions already installed. You'll see on the left-hand side there are a number of Docker tools. You want to expand the Docker Compose section, select Install Compose, and then on the right-hand side you'll have different install options for Mac, Windows, and Linux. If you're installing on those platforms, make sure that you're copying the correct command lines. There's a couple of command lines you want to copy. Copy the first one over and we paste that in, and it's going to go ahead and download all of the files for Compose. It takes a while, but we have to get another file, so while it's downloading we'll go get the other command line. Just go back and grab it real quick. It was a little fast there, but we'll copy that over. There was a second command instruction and post that command. Yep, there's the command right there. And that will apply the appropriate binary. And once you've done that, you can actually go ahead and validate that you have the correct version of Docker Compose installed. And for that, you want to write the command docker-compose space -- version. And that will then give you a version build. Once you know that you have a version build, that means that you have everything installed correctly on your machine. So you can see here that we have a version number, which means we have everything installed. You might see a different version number depending on how old the video is when you're watching it, but we're using very content at the moment. And just go ahead and clear the screen. And now what we're going to do is create a folder where we're actually going to install the YAML file that will have the instructions for our Docker Compose environment. So we're moving the cursor to the desktop, and on the desktop we're going to create a new folder and using the mkdir command, and we'll call this one Docker Compose F for file. And then we'll move the cursor into that new folder by using cd command. And now we are in the folder called Docker Compose F. And you can go look at your desktop and you'll see it's there. And now you want to select #touch docker-compose.yml, and that will actually create the new YAML file for you. And you can use the ls list command, ls docker-compose.yaml, and that'll allow you actually now to step in and edit that file. So let's go ahead and hit return, and that'll allow us to go in and edit the file. So now I'm in the editor and I'm going to write some instructions. So I'm going to put a couple of mistakes in these instructions so we can see how Docker Compose catches those mistakes. But most of this is going to be fairly correct, so you can just type this out. So we're going to start with services : then we'll do web : and then we'll create image : and we'll do Nginx, and then we'll do a database : and we'll call the image Redis. And so what you can see, because we have two reference images, we're actually calling two different images, two different containers that will be created by Docker Hub. So what we're going to do is where we can actually show you how that's pulling in. You can go to Docker Hub and you can actually see the references to the images that we've just created. So go to Docker Hub, which is hub.docker.com, and you'll see that Nginx, Redis, those are the default names for the images. So you could do other images like HTTP for Apache web server if you wanted to. There are a lot of images in Docker Hub, so certainly have a lot of fun building tools from that environment. So we're going to save those files in the Docker image, and we're just going to do :WQ to exit this screen. Save the text. Let's go and run our YAML file, and you'll see the two different error messages that will come up. So we're going to do cat docker-compose.yml, and here we have a display of the text that we just wrote. And now let's go check the validity of the file that we just created. So we'll do docker-compose config, and we should get an error message. And there we are, error message. And the reason why we have an error message is because the spacing is not correct in the YAML file itself. So let's go to the actual YAML file that we created. Let's go through and we're going to use just the file finder, and you'll actually open up the YAML file in your text editor, your favorite text editor. And here we have the code that created it. And let's use the correct spacing so that everything is spaced out appropriately in the image. And so this is the spacing that you'd expect to see, a line between surfaces and the first image, and the first image is a tab in, and then it references what the image is. And let's go ahead and clear the screen and we'll see whether or not we've got that all correct. Let's clear the screen, and we're going to check that everything is running correctly. And we're still getting an error message. And the reason why we're getting another error is that there's still a config error in the actual YAML file. So one of the things you have to do when you're creating a YAML file for Docker Compose is you actually have to have the appropriate version number in there. So what we have to do is we have to go and find which is the appropriate version. And there are 3 major versions, 1, 2, and 3, depending on the age of Docker that you have installed on your computer. So if you have the very latest version of Docker, 18 and newer, you would put 3.7 as the version number. And what we're going to do is we're going to just check on the version that we have installed. And so we'll just clear the screen, and then we'll just do Docker version. And what we have is our version of Docker is 17.12. Now this is the version of Docker, not Docker Compose. It's your main Docker environment. And so if we go back to our web browser, we'll actually see that version 17 should align with version number 3.5. Yep, there we are, version 3.5. So what we want to do is go back into our YAML file, and the very first line that we want to put in above the services is the version number. And that version number we're going to put in is 3.5. So we type in version, and we put colon, and then version number is in quotes, and you save that. And now what we can actually do is we can actually go ahead and use the single line instruction to run both of these 2 images that we've created, because everything is configured correctly. But with just one note, you'll see that the version number is actually at the bottom of the list, and that's just the way that Docker Compose works. It pulls out the services and the images that you'd create, and then puts the version number at the bottom of the list. So in the presentation, we talked about how you can use one line to trigger 2 or more images. And so to do that, we're going to do sudo docker-compose up-d. And it's going to create the 2 environments. We have the web environment and the database environment. And let's use sudo docker ps to actually list out all the processes that are running right now. And there we are. We actually see all of the images that are running. We have the names, the commands, the images, and everything's up and running. And if we want to close both of those images, we can actually use a single line of command as well. And that command will be sudo docker-compose down. And that closes both of the images. And we can see that all the databases and the web services images have been closed, and sudo docker ps will actually list that there is nothing running. And that's how to use Docker Compose.
Why exactly the Docker networking is it important? Let's talk about some scenario over here. So my application is something which totally works perfectly fine into my system, and there is no issues on there. I ran it perfectly fine and I got the response. I'm able to interact, everything I'm able to do. But the same application does not work on the other person's system. Now what could be the issue? Because it's working on one machine and it's not working on another machine. Now the application does not work on another system because there is a difference in the computer systems. Maybe one system is having a different machine and another system is having a different machine, and you may be having some of the differences, maybe in the term of hardware, maybe in the terms of software. So the differences are possible in 2 different machines. So how we can get a solution that we don't get this kind of problems, and once the container is prepared, it should be able to run it across different systems. So Docker networking is the ideal solution for this problem over here. With Docker networking, the application works totally fine, and it's something which can work on any system. You don't have any dependency that it will run only on a specific machine or a particular system. So what exactly is in Docker networking all about? So Docker networking enables a user to link a Docker container to as many as networks he or she requires. So you can actually connect a Docker container to a specific network. The Docker networks are used to provide complete isolation to the Docker containers. So you can have it like, okay, I want to run some couple of containers in a different network, and another containers I want to run it into a different networks. So you can do that isolations, and the whole purpose of doing that isolation is so that we will be able to have a proper networking and proper executions and all that stuff. So Docker networking is a very important concept when we talk about, or when we come up with the interaction or having the Docker containers isolated. So it resolves most of the problems. Okay, so you can have like multiple containers in running in same network. You can have different particular networks also there. So a specific network have its own attributes, and then you can use those attributes to connect to that containers and to access that containers. But the whole idea is that the containers are something which is specifically running in a set of servers or in a set of platform. So whenever I'm trying to look forward to that particular container, it has to be there into a network. If you don't run it into your custom network, then whatever the default network present, it will be hosted in that network there. So how does the Docker networking actually works? So you got a Docker file. So using the Docker file, you got a custom Docker image, and from this Docker image you have to actually go there and put up like the Docker container. So you can also store this Docker image to the Docker Hub, so that the same Docker image can be shared across different users, and they can also pull down their Docker image and they can have the container running in their systems. So for the collaborating the Docker image, you require the Docker Hub, and the container is the ultimate thing or object which we need to create out of the Docker image. When we go with the particular process, when the whole process goes on over there, so what happens that instead of the Docker Hub, you can use your own private repositories also. That's something which totally relies onto you, that how exactly those things works on. So a Docker file creates a Docker image using the build command. A Docker image contains all the project source code, all the dependencies. Using this Docker image, you can actually run the source code in order to get a Docker container. The moment you initialize or run an instance of Docker image, you will be able to get a Docker container. You can actually use the Docker Hub for collaborating or for sharing the Docker image. So you can store the Docker image on Docker Hub, and then different people can actually go ahead and download or pull this Docker image onto their system, and they can also run their specific containers. So what are the different advantages we get with the Docker networking? Very first one is the rapid deployment, portability, better efficiency, faster configuration, scalability, and the security over here. So these are some of the advantages which we get when we talk about the Docker networking here. Now let's talk about the container network model here. So what is the network model we are looking forward from the containers perspective? Now this is a kind of a architecture here. Now in this one, let's see that how it actually works on. Now you have a Docker engine, which is a main component which takes up all the things, and all the important components are actually integrated with each other. Now the network sandbox is the one in which you will be having your container running up and running. Now every network is having its own attributes, the particular different gateway IPs, the IP addresses, the range of IP address, the CIDR blocks, also everything can be different for two different networks. So the whole point is that you will be defining, okay, if you don't define that I want to run this particular container into a specific network, then definitely that's going to run into a default network which gets created the moment you do the installation of Docker. But anyhow, any network is required for running a Docker container. So there are different network drivers which is available there. So if you feel that you want to create a network, so you have to choose a particular networking or the connectivity over there, and it really helps us to understand that how the configurations and how the different modifications and those changes can be really done here. So a lot of changes are actually going on and performing there, and this really helps us to understand that how the things are being done as such over there. So network is something which is very important from the containers perspective. So the network sandbox is a kind of a isolated sandbox that holds controls all the network configurations of the containers. So you will be requiring at least one Docker container network if you want to run a container in that particular sandbox. So sandbox is created when a user requests to generate an endpoint on the network. So that's where the sandbox gets created. It can have several endpoints in a network as it represents a container's network configurations like IP address, MAC address, DNS name. So every container will be having its own unique IP address, right? So that can be a particular endpoint to connect to that container, and it can have it like different endpoints and different networks. So that's always the possibilities which is available there. Now the endpoints establishes the connectivity for the container services with other services also. So the moment you work on the particular endpoints, so that can be used for having, okay, there is a service running in a container, so how you can do that. So if you, in order to connect that, you require these endpoints so that you can establish the connectivity with the container services, whatever running inside these Docker containers. Right now, the network is something which provides the specific underlining network attributes like the networking support to the Docker containers, because these network sandbox boxes will definitely have a requirement of the network. So how you're going to get that you will be only able to get when you go, okay, I will be looking forward for the connectivity and I can go for the communications and I can give the hardware, because although it's a OS level virtualization, but still you require some interaction with the hardware from the networking perspective. And then Docker engine is the base engine which is installed on the host machine, and it's actually the main component which makes sure that the Docker containers and the corresponding Docker services are always up and running. And the using the network drivers, you can actually create multiple networks onto your system and you can have those configurations. Now the network architecture is something which helps us to provide the connectivity among the endpoints that probably belongs to the same network, and it's something which is a kind of isolated network. So different networks can be isolated networks, and we can have the endpoints to them. So there are different ways in which we can establish the connectivity, and this is a complete network architecture which is there. So you have a network drivers, you have the networks, you have the network sandboxes in which internally the Docker containers are running, and then these network sandboxes are having their respective endpoints there to access them to establish the connectivity. Now let's talk about the network drivers. Now there are 5 type of network drivers which is available. First one is the bridge, host, none, overlay, and MAC VLAN. So these are the different particular network drivers which is available over here. First one is a bridge. It's a private default network created on the host. If you go there, if you go to the installation of a Docker, this is the default driver which gets installed onto the system, onto the host. The containers linked to this network will have an internal IP address through which they can actually communicate with each other. On the same machine also, you can establish the connectivity. You can connect to the containers using that private IP address, but outside the server you will not be able to have the communication, but internally you can connect to the containers, and containers can also interact with each other. They can also communicate with each other with this one. The Docker daemon creates the Docker 0. So if you run the IP config or if config on the system, you will be able to see a Docker 0 kind of Ethernet bridge network which is created, using which you can see that, okay, this is the network which is created by default. It's a default installation or default configuration which automatically happens the moment you set up a Docker instance. So you don't have to go into the configurations or in the setup of there. It will be already available on that particular installation mode there. And the next one is the host one. So it's a public network. So when we go with the public network, it's actually uses the host IP address and a TCP port in order to interact with the service running inside the Docker container. So if you are looking forward that I want to reach out or I want to connect to the container, but I want to use an IP address which can be accessible from outside world, probably some other server should be able to resolve that. In that situation, the host network driver comes into the picture. So it effectively disables the network isolation between the Docker host and the Docker containers, which means that using this driver, a user can actually run multiple containers. You know, it's not possible for the user to run multiple containers on the same host because of the fact that you are using the host IP address. Now when we were talking about the bridge connection, at that moment of time we were getting the private IP addresses which was totally isolated and totally unique. So there were actually, if you create using the bridge connection multiple containers, so you will see that if there are 5-3 containers, everyone will be having a different private IP address. But the moment you go for the host one, so in that situation the IP address is not going to change, so you get some restrictions, okay, because the combination is of IP address and port. So IP address and 8080 can happen only once, it cannot happen multiple times. So that's a limitation, that you cannot run multiple containers on the same host due to this restriction. And next one is the none. So in this network driver, the Docker containers will neither have any access to the external network, or it will not be able to communicate with the other containers also. Total isolation and total private containers are being done when we use this driver. So if these options are usually used when you want to disable. So this is not doing nothing but disabling the total networking functionality for a specific container. That's what is happening over here. Next one is the overlay. So this one is utilized for creating an internal private network to the Docker nodes in the Docker Swarm cluster. So overlay does not comes up in case of a standalone Docker installation. The moment you go with the particular Docker Swarm cluster, at that moment of time the overlay type of network is created. So Docker Swarm is an orchestration tool, so that requires a overlay kind of driver which can help them to achieve the networking in case of cluster, because in case of Docker Swarm you have a master node, manager node, worker nodes, different machines are there. So in that situation overlay is the main component, or is the main type of driver which is used. And then we have the MAC VLAN, so it simplifies the communication processes between the containers. This network assigns a MAC address to the Docker containers. With this MAC address, the Docker servers will route the network traffic to a router. So it's not on the basis of IP address, it's actually on the basis of MAC address. So on the specific MAC address, the network, the Docker server will redirect the network to a specific router. Right, it's usable when a user wants to directly connect the containers to the physical network rather than the Docker host. So that's where this communication works on. So it's a direct connectivity between the host network and the Docker container. So there is no virtualization which is happening over here. So it's something which is giving a direct access to the networks, but it's definitely on the basis of MAC address on which the communication is happening. Now let's talk about the networking implementation, and we'll see that how we can go for a particular bridge network implementation there. So let's go back to the virtual machine. So I am connected to a particular system here, so I can check that if the Docker is available to me, and I can just run the Docker version. So it says that okay, the client and the server component both is available there. Now we are going to see that what are the different containers which is what are the different Docker containers network which is available there. So I'm going to run a command called docker network ls. Now the moment you do it, over here you will see that none, host and bridge, these are the different containers network which is available there. And you can see their network IDs, the names, the drivers. The drivers is also very important because that's what we are going to use here. So it's a very good one here. So the default one, you can see that the bridge is available, and it's a default one whenever you create any container. By default, whether you give the container attribute or not, it's something which gets created into the terms or in the basis of the container only, in the default network only. So how we can get that? We can always get that part by having the understanding that what network we are using. So I'm going to run a couple of containers or small container, and we can see that how exactly the containers can be executed and can be done over there. Right, so let's see. So I'm going to run a command, docker run -dit -name alpine1 alpine image is what I am going to use, and sh. So it pulls down the alpine image. That's what it happened, and the same thing I'm going to run, but this time I'm going to run alpine2 because I want to create two containers. right? So with this one, what will happen that I will be having two containers available here. So I can say like docker ps. So I can see that two containers are running. One is the Alpine and one is the Alpine 2. Right. So now what happens that we will see that how the connectivity happens and what are the network details. So what I'm going to do is that first of all I'm going to do an inspect over there onto the bridge connectivity so that I can get the detailed information. So this is the name of the particular ones of the network. So this is the network which is available and this is the default one. So if I scroll up, you can see that this is the name of the bridge connectivity, and even if you run the docker network ls, so you will be able to see that the ID also. So ID also, if you compare, so E65, that's the one which is available. Now this one is something which is using a driver called bridge, and here you can see the subnet information. Now if you scroll down, you can see that two containers are available here. So I did not provide any kind of network details, but definitely what happens that the two containers which I deployed are basically running inside this network. Okay, and you can see that the bridge name docker 0 is the internet network which gets created which during the installation of docker gets configured. Now you can see that this is the IP address, this is the IP address here, this is the MAC address, and this is also a MAC address here. So the IP address, you can see this is a 3.0.3 in the last, and this is .2 over here. So you can see that the sequence is there. So Alpine 1 was having an IP .172.17.0.2, and Alpine 2 is having an incremented IP address like a different one as in 3. So you can see that these different IP addresses are there, and represents if you want to access them, if you want to connect on them, you will be able to have the connectivity accordingly. So even if you go inside these containers, you can actually see that what exactly the connectivity you want to establish or the connectivity you want to perform here. Right, so this is the way that how the network usually works, and the networks bridge you are using over here is the bridge ones, which definitely helps us to understand that how the configurations can be done. Now, so what we are going to do over here is that we will try to see that how exactly we can go ahead and we can connect on there, and we can also see that if we are able to communicate with each other, because probably if I run like ping command over here, and I'll put the containers like 2, and I'm able to reach out. There is no problem in reaching out to these IPs because these are the private IP addresses, and I will be able to reach out to them without any problem and without any concerns. So from the current connectivity perspective, there is no problem as such, and I have a connection available over here. But let's see, we'll go back to the containers. We'll see that how exactly we can talk about, we can reach out the one container with each other. So I want to connect Alpine 1 with Alpine 2, so how we can do that? So I'm going to use like docker Alpine 1. Okay, now I got a terminal. So what I can do is that I can go for the IP address show. So with this one, what will happen that I will be able to know the IP address. So .2 is the one which is available over here. Okay, so this is the IP address. Now I can simply do the small ping command. So I can say like ping google.com, so that will show me that if I have an internet connectivity, so that is great. So I got a connectivity with the internet over there, so I will be able to reach out any websites or any kind of that order. Now I have another IP, so .3 is, remember we were using the different IP, so I can actually do a ping also here. So ping -c5 request will put, and 3 will do here. Now we are trying to reach out to the Alpine 2 over there. So although we are connecting to the Alpine 1, but we have the connectivity with Alpine 2 also. So from Alpine 1, you can connect to the Alpine 2 containers. So that shows that since both of them are running in the same container, so they are having the automated connectivity, and you can easily reach out to them, and without any issues you can do that. And similarly, the same thing you can do it in case of Alpine 2 also. So you get it connected to the Alpine 2, and you can just follow the same thing. So you can connect it with the, if you go to the Alpine 2, you can connect to the Alpine 1 also. So if you come out, the containers will be always up and running, and you will be able to have the mechanisms there. So the whole idea about these things is that it will be basically helping you to understand that how the executions can be done and how we can perform the activities as such over here. So this is the way that how we deal with the networkings and how the containers gets created into a network, and then they can interact with each other, right? So this was the demo on which we talk about that how we can talk about a bridge network implementation with the Docker containers.
Did you know the famous global researcher Gartner predicts by 2023 more than 50% of the companies will be adopting Docker containers? However, a serverless container like Docker will have a rise in the revenue from a small base of 465.8 million in the year 2020 to 944 million in the year 2024. In this video, we will be doing a side-by-side comparison of the Docker containers and the virtual machines. What exactly is a virtual machine? It is an isolated computing environment that enables a person to use an operating system via a physical machine. Virtual machines provide the functionality of a physical computer. As you can see on my screen, there is a virtual machine, and this is how a typical virtual machine looks like. Now, let's look at what a Docker is. Docker is an operating system level virtualization software platform that enables software developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. And a Docker container is a lightweight software package that includes all the dependencies like frameworks, libraries, and many more, which are essentially required to execute an application. This is the architecture of Docker tool. Now let's move on to our next main topic for the discussion, that is Docker versus virtual machine. When it comes to comparing the two, we could say the Docker containers have much more potential than virtual machines. As you can see on the left and right hand side, both the images look similar. Now let's define the layers of virtual machine from the bottom up. Let's begin with the infrastructure. Infrastructure could be a computer system, a laptop, or a virtual private server such as an Amazon EC2 instance, or Azure virtual machine, or GCP virtual machine instance. On the top of the infrastructure runs the operating system. An operating system is a software that manages hardware and software resources for the computer programs. On your laptop, this will be likely Windows, Mac OS, or Linux flavored operating systems such as Ubuntu. Next comes the hypervisor. A hypervisor is a firmware that builds and runs virtual machines. There are two types of hypervisors. Type 1 hypervisors are HyperKit for Mac OS, Hyper-V for Windows, and KVM for Linux operating systems. And Type 2 hypervisors are VirtualBox and VMware. Then we have the guest operating systems. Consider an example where you want to run two apps on your server in total isolation. This process would require two guest operating systems which will be controlled by a hypervisor. Virtual machines come with many dependencies where each guest operating system will at least occupy 512 MB of your RAM. This is worse because each guest operating system needs its own CPU and memory resources. Eventually, this will be expensive. Then, on top of that, each guest operating system requires its own dependencies such as binaries and libraries. Since every application has different dependencies, it requires its own set of libraries. Finally, it's the application. This layer consists of the source code for the application you have built. This was all about the virtual machine on a server. Here's what the same setup looks like when you're using Docker containers. Here, you'll notice that there are a lot fewer layers. Docker doesn't require a bunch of massive guest operating systems. Let me break it down from the bottom up again. Infrastructure and host operating systems are the same as we discussed for the virtual machine. Coming into the third layer, instead of a hypervisor, Docker uses Docker Engine. Docker Engine or Docker is a client-server application that builds and executes containers using Docker components. Next, we have our dependencies. Just like on the virtual machines, here dependencies are built into a template called Docker images. As you can see on the screen, each application is still isolated and occupies less space. Now, let's have a look at the significant differences between Docker and virtual machine. Let's start with the operating system first. Docker is a container-based model where containers are software packages used for executing an application on any operating system. On the other side, virtual machine is a container-based model. It utilizes user space along with the kernel space of the operating system. A kernel space is where the core of the operating system runs and provides its services to the user. A user cannot modify this space, and user space is the portion of the system memory in which the user's processes run. Docker containers share operating system kernels with other applications and result in a higher server efficiency. Hence, Docker provides the most substantial default isolation capabilities among the other configuration tools. On the other hand, virtual machines do not share the operating system. Also, it does not provide isolation in the host kernel. In Docker, multiple workloads can run on a single operating system, but in virtual machine, each workload needs a complete operating system or a hypervisor. The next significant difference between the two is the performance. In the case of Docker, they use the same operating system without any additional software like hypervisor. In case of virtual machines, performance issues are a major problem. It can be due to the several reasons like CPU constraints, memory allocation, network latency, and many more. Running multiple virtual machines lead to an unstable performance. Docker containers can start up quickly and result in less boot-up time, whereas virtual machines do not start quickly and lead to a poor performance. Now, let's talk about the next difference, which is portability. With Docker containers, a developer can build an application and store it into a Docker image. Later, he or she can run it across any host environment. But when it comes to virtual machines, it has portability issues. Virtual machines do not have a central hub like Docker does, and it requires more memory space to store data. Docker containers are smaller than virtual machines, due to which the process of transferring files on the host file system is easier. On the other hand, dependency on the host operating system and hardware makes virtual machines less portable. While transferring files, virtual machines should have a copy of the operating system and its dependencies, due to which image size is increased and becomes a tedious process to share data. The boot-up time between the both is very different. The application in Docker containers start without any delay since the operating system is already up and running. On the other hand, virtual machines take much longer time than it takes for a container to run applications. These containers were basically designed to save time in the deployment process of an application, whereas in virtual machines, to deploy a single application, virtual machine needs to start an entire operating system, which would result in a full boot process. So those were the major differences between Docker and a virtual machine. Now let's discuss the minor differences between them. Docker is not always in a running state. It stops when the stop command is executed, whereas the virtual machines are always running in the background, which will result in huge RAM consumption. Talking about snapshots. Docker has a lot of snapshots. A snapshot is an image that you can upload on a private repository to access it on another host. But virtual machines do not consist of any snapshots. In Docker, images can be version controlled just like Git. They have local registry called Docker Hub where users store and distribute container images. On the other hand, virtual machine does not have a central hub. They are not version controlled. Docker can run multiple containers on a system. Users can connect multiple containers using user-defined networks and shared volumes. Multiple containers can be accessed on the same machine and share the operating system kernel with other containers. Each container is isolated in user space. Also, Docker containers occupy less space than virtual machines and start instantly. Virtual machine can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Multiple containers can be started at a time on the Docker engine. The isolation environment allows a user to run and deploy several containers simultaneously on a given host. Virtual machines can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Now that I have told you the differences between Docker containers and virtual machines, let me show you a real-life case study of how BCC uses Docker. BCC News is a British news channel over 500 developers working across the globe. BCC News delivers broadcasts in almost 30 different languages and with over 80,000 daily news in English alone. The news channel ran more than 26,000 jobs with more than 10 continuous integrations with sequential scheduling. The company had issues with identifying a way to unify the coding process and monitor the continuous integration consistently. Also, the existing jobs took up to more time, that is, up to 60 minutes to schedule and perform its task. Docker allowed BCC News to eliminate job wait times and run jobs in parallel. It also gave the users the ability to work in a more flexible CI environment where entire code processes were unified and stored in a single place. However, Docker succeeded in spreading up the whole continuous integration process.
In this topic, we are going to talk about what exactly is the various Docker commands which we can use to interact with the Docker images, Docker containers, and some core components of Docker is what we are going to talk about in this particular topic here. Now let's begin with what exactly is in Docker, because we are trying to explore that what are the different Docker commands we can eventually run to interact with the Docker, because you have the command line interface which is available there, using which you can run some couple of Docker commands, and internally you will be able to have some particular processing which is done at the Docker end. Now Docker is a configuration management tool. It's being used as a configuration management tool just like the other configuration management tools in the industry, in the market. Now it's pretty much used by the developers to make sure that they wrap or they package an application with all its dependency. Now normally in a virtual machine what we do is that we host or we install the dependencies separately, and then on top of that we host our web applications or whatever the application we have, we host it on that particular framework or platform. But here in this scenario we are talking about like how we can wrap an application all together with its dependencies. All the dependencies are getting wrapped, are getting packaged up into a single entity, and that's what we call it as a Docker container. So Docker is a configuration management tool and a containerization tool which is there, which helps us to wrap or package both the dependencies and the source code within a single unit called Docker container. And this is the Docker container which the developers use to do the deployment across multiple environments. So as part of the process, when you are working on the hosting of your application onto your Docker, so ultimately you are looking forward for an entity called Docker container. So if you go through the diagram over here, so in this one, this is in kind of a basic way architecture that how the Docker is being architect and is getting deployed. So initially you have an infrastructure, like a physical infrastructure is there. You have the particular cores, memory, infrastructure, all those things are available there. Now on top of this infrastructure you are hosting up a host operating system. This host operating system is responsible for taking up all the requests and interacting, providing a particular interface between the particular Docker and the infrastructure, the core hardware. So it acts like a medium over here. So after the host on operating system, on top of that you are going to install the Docker engine, Docker software. It's just like you got a virtual machine on Linux, and on top of that you are installing the Docker software. Once the Docker engine is installed, then Docker engine will take care of management of the Docker containers. You don't really have to do a lot of work. Docker engine is going to take all the internal work, the communication between the operating system and the infrastructure, so that needs to be done by the Docker engine. So Docker engine makes sure that the different container gets up and running, and you can see that in this scenario, in this diagram, we have container 1, container 2, and container 3, and all these containers are actually having its own applications and the dependencies binded up together. So that's the reason why we are saying that with the Docker we are getting a complete package. End-to-end package is being given to us, in which we have both the particular source code and the binaries and the executables embedded inside that. So it's a complete package which is getting created in the form of Docker container, and the developer is responsible for preparing this Docker container so that these containers can be deployed on the Docker host and you can get your application up and running. So this is what we have Docker into a particular and the architecture of the Docker here. Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own. Right? So in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a kind of a Docker build script. Just like in case of Maven, we have pound.xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you are trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up. The custom Docker images are built up with the help of Docker file. So docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now how to list down all the Docker images. So docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete an Docker image, so you can go for docker image rm command to remove a Docker image completely from the Docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the one attribute where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of Simplilearn, or whatever the name you want to give. You can
give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that for what purpose you are preparing this image. And with that, what will happen, that it will take up the values, whatever attributes you have put up into the Docker file, so that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like Docker image rm and Simplilearn. So if you do that, what will happen, that your Docker image which is related to Simplilearn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of Docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called Docker image and then rm command to remove the Docker image from your system, from your host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container, and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command. But the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as in particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container you can rename it with a new container, and that's how the particular rename of an existing container will be done with onto the Docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your Docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we are going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that, and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's an heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps-a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a Docker container here. And the created status also shows that yes, the Docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run Jenkins, and what it will do, it will definitely help you to get the container created onto of the Jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself, that whole Jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a control C over here, because it says that Jenkins is up and running. So you can start using this one according to your requirement over here, right? So I'm just doing control C so that it can be stopped over there, right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available, but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_Jenkins. So that you can easily do with the help of docker rename command, because that will rename the Docker container name, so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now, if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container, but we do not remove it from the Docker host, because we are not going for the cleanup. Now, cleanup is very required, because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup purge of all the containers which is running on the host machine here, and that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this really completely removes all the stopped containers onto the Docker host over here in this scenario. Now second one is that it creates a new image from a containers file changes. Now the way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such. What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do here is that in order to see that how we can actually remove all the stop containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is in up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where, for example, we have got some stopped containers, but again, you have to manually remove them one by one. Now, if you don't want to do that stuff, if you feel that whatever the stopped containers which is available, that should be automatically removed from your system, then we have a command called docker container prun. Now, for this, what we really need to do is that we need to actually stop this container, because again, it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prun command over here in this one. And then I can run like docker container prun command, which will basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular Docker image. Let's say that we got a Docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a Docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a Docker image. So all you can do is that, let's say, let again run a particular container of HTTPD here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes. Now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit, that's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be again copying that particular container ID, and we'll say like custom image version 1. So we will be giving a custom name or a name of a Docker image and a tag over here in this one. So this will basically save my Docker container which is available in this one in the format of a particular Docker image, in a format of a Docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this whatever the changes you want to do, you can do that, and you can then put it up into the form of a Docker image, a final Docker image. And at last, if you want to remove it, so docker rm and container ID. Now this again docker rm will remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So docker ps-a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content. Right, so these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new Docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system. Right, so once the container is restarted, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one. Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will be list down on all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it, now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that docker container list is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content. And then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container, and it will go in the wait status. So docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you because the container is in stop status. So again you have to do the restart of the container to make sure that the container is up and running. right? So the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again, I had to restart that container over here in this one. Then again, of course, we have like docker wait, then container is there. So this will basically put the container into a block status, because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output. And lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0. But in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how where you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker Hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the Docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done, and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. All you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest. So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull a MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub, and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same if you run docker push custom image version 1. So if you do that, it will not be pushed into these particular Docker Hub. So it's going to throw an error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise, it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image. The same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like Docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does requires the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations. But let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d HTTPD, like I'm just running a dummy container over here so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you, so you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now in order to log into the Docker Hub, because before doing the Docker push you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the Docker login command, where you can see that how the execution can be done. Now using the Docker login command you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that okay, the configurations is done, and we can go ahead and we can perform the execution. So docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see the history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again if you try to run Docker login you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one, so the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system, which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the docker volume create command. So docker volume create command is there, using which you can create the docker volumes, and you can pretty much do that setup. So docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out at what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the Docker swarm commands here. Now Docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So Docker swarm is there where we can see that how the execution needs to be done. So you can go for the command called docker swarm init command. This will actually go for an initialization of a Docker swarm cluster, and once the Docker swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that, and you can execute as such over there. So docker swarm init is the command using which you can actually see that how the execution needs to be done, and how we can perform the mechanism and the changes over here. So docker swarm init -- advice adr address is there, which helps you to see that how the executions can be done. Now joins, you have the docker swarm join command which is available there. Now if you go for docker swarm join command, so you can have a particular host. So docker swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the docker swarm cluster. And then if you want to leave from the swarm cluster, then you can go for docker swarm leave command, and it will be simply removed from the docker swarm cluster there. Some of the couple of commands using which we can initialize or we can remove from the docker swarm cluster here. So docker swarm is already being initialized or is being created when the moment you do the installation of docker. So docker swarm init is the command using which you can initialize a docker container. Now once you initialize over here, so after the initialization, you got a command which you want to add it, like you want to run it onto the docker swarm cluster. It will act like a worker node, so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your docker swarm cluster, so all you can do is that you can say like docker swarm leave -f, and you will be left out of the docker swarm. And now if you want to run like docker node ls, you will not be able to get that output, because it's saying that there is no particular swarm manager which is available. So you can run docker swarm init, or you can run the join command to connect to that specific node, but we have already left it, and nothing is available over here. So that's a way that how you can manage like what are the different docker swarm commands we can typically run to manage the docker swarm cluster. Now let's talk about the docker compose commands. Now docker compose commands is actually there using which we can create multiple containers. It's not only one container which we can go for multiple creations of the containers with the help of Docker Compose file. So Docker Compose -version is the command which we can give you the version of Docker Compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services, that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file we can create, or we can have that particular Docker Compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification, so that you will be able to have the modifications done, and you will be able to find out a particular multiple containers gets created all together. So Docker Compose is the way that how you can do the setup. How you are going to run the Docker Compose file? So in that case you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker Compose one. So let's try to run some commands related to Docker Compose. So docker-compose -version will let you know that what exactly version of Docker Compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install, so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker Compose file. So what we need to do is that we need to create a docker-compose.yaml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing, because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080. So, or sorry, 80 is what you can dash for the Nginx because it runs on 80 port. But now I have to run like 80 port. I want to dash that port over here in this one. So I can specify that 80 port should be available in this one. So I'm going to save this one here, and I'm going to run a command called docker-compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode and it will be executed. So it will process your Docker Compose file, and since you have used a standard name called docker-compose.yaml, so it will automatically pick that Docker details and start creating the container.
Kubernetes is an open source platform used for deployment and management of containers. So let's get started. Now, the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates. And then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt-get install curl. So you have to select Y and this will take few minutes. So moving on, the next step we have to do is download an add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key and then we have to add it using sudo apt key add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now moving forward, now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that. Sudo swap off -a. Now let's go ahead with the initialization. Sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster, we have to use these three commands. Let's just copy paste it. Okay, that's done. So, moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, we have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster is very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. And you really want to let Kubernetes do this, because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right-hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left-hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left-hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you are probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's lifecycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filtered, organized, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password. And this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https. And this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency. And the way we do that is write the command sudo apt install docker.io. Got a typo, correct that quickly. And put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. And we're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So the first, what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl -s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc /apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db httpt apt-kubernetes.io /kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do cat /etc/etc/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install Kubelet 2 and ADM. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install Kubelet and the other files too quickly. You get the following error. All right, so we have installed Kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-file.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube/config. And then the final one will be sudo chown $open paren id-u close paren $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, I think I have a typo in my command here. Yep. Oh, yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network. And so we're going to do that by writing the command sudo kubectl get pods -all -namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes, There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service. And we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80. So it's going to be nginx-app --port equals 80 --environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app --port equals 80 --name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. And there we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful. We're going to take a deep dive into the Kubernetes architecture. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. So you have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of 4 key areas, which essentially control all of your nodes. And the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself, and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually, you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pod, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction and part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer and increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
Kubernetes specific to AWS Cloud Platform. What are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that the application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management: Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50 or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto-scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very strong. They are very tightly coupled, and even they have the capability where on the cluster size things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes groups containers in something called as pods. While a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled, based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point. In case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads, you can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the Kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the Kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node and what should be existing in a worker node? You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server so that my EC2 server gets powered with all the required role so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account and let me stick to one particular region and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right. I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called Open to the Word. I would not recommend that you do this since I don't want to. It will take a long time for me to specifically pick and choose the ports that has to be opened for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I opened up all the ports and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from a Windows box. I would need to convert this into a PPK file. So I have puttygen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's all. So this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly kops role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I'm going to review. I'll create a role name. I will say kops role for EC2. Alright, so I'm going to create a role which has got administrative access role. So I'm going to create a role So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. Alright, now let us have our running instance get powered by this role. So I will connect this role to my running instance. Alright, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. Alright, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. Alright, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. Alright, so I have kubectl as well as COPS installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. Alright, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. Alright, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. Alright, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. Alright, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already have it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and 2 worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with 1 master server and 2 nodes or the worker nodes. All right, so this is the command for me to validate the cluster. And I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only 1 server that I had started, which was my kop server, and automatically the other 3 instances, one is called nodes.simply.in, these 2 are the nodes, and this is the master node. So these 3 got automatically provisioned by the kops command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this kop server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my kop server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as yeah, I'll just expose this. Let me see. All right, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I will say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. kubectl delete service. I want this. Alright, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. Alright, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the cops server, which had cops installed on it, is now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
In this video, we're going to cover a common conversation, which is Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problems specific companies have actually had and how they're able to use the 2 different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing 2 primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the #1 container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list. Let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms, and then finally, for space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution part that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you're going to be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked how to create a Docker container. So let's go through what that would look, and we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have Docker Registry is an open source server-side service used for hosting and distributing Docker images, whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix. You could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Dockerfile, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these our expose 8080, or with Docker we would put in, or for publish we would do the example docker run -d-p and then 0.0.0.80 as our command line. In this video, we're going to take you through the 30 most common questions that you are likely to be asked in a Kubernetes interview. We're going to break up the interview questions into 3 categories. It's going to be beginner, intermediate, and advanced. The beginner questions are really going to cover about 3/4 of the questions that we're going to ask here, and then the intermediate and advanced will finish out the final quarter. And the reason is that quite typically most interviews you'll be asked intermediate to beginner level questions, mainly beginner level questions, just so you can demonstrate your understanding of Kubernetes. And then there's always one advanced question that gets thrown out just to make sure that you really do know what you're talking about and you've done at least 1 or 2 Kubernetes environment setups to be able to validate your experience. So let's kind of jump into that first section, which is, why is Kubernetes widely used? And your answer to this really comes into the fact that Kubernetes is widely used because of 3 distinct areas. One is that Kubernetes is an open source platform that is readily available for the management of containers and allows you to manage the deployment, scaling, and management of those containers. And so the first area is that it allows you for easy deployment of your containers, the ability to scale effectively within Kubernetes, not just vertically but horizontally for your containers. And then finally, the Kubernetes environment itself was really designed to make it easy to manage containers in small parts. Other key areas of why Kubernetes is popular is that Kubernetes is the single largest open source project out there. Since its launch in 2014, it's just grown in leaps and bounds. Around that project, there is just a huge community, both an online and physical community. There are just a large number of online groups that are supporting Kubernetes and allow you to get fast access to information. But in addition to that, there are also a lot of local meetup groups that cover specifically Kubernetes, whether as part of a DevOps group or as part of a dedicated Kubernetes group. The actual environment itself is a really robust way of being able to manage your containers. Containers are becoming the most popular way of being able to deploy cloud-based applications. Kubernetes is an effective and persistent storage environment. So Kubernetes is also able to effectively manage persistent storage, whether it's local storage as a SSD drive or a local hard drive, or whether it's cloud-based storage. And because of the way that Kubernetes is architecture, it's really designed for the cloud from the ground up. So it's a great way to get started in building out your cloud solutions. And then finally, the actual tools within Kubernetes are designed to help and manage the health and monitoring of the environment itself. So what is Google Container Engine? So the Google Container Engine is another open source solution, but it's designed for managing the Docker containers and clusters. And so Kubernetes is a container management solution, and Docker is the most popular container solution out there. And this is just a way of being able to bring the two effectively into each other, so that you can have Docker containers manage the application, and then Kubernetes manage the scale of your applications as they're vertically and horizontally scaled across your network. So what is the difference between Kubernetes and Docker? And this is important because Kubernetes and Docker are often dropped in the same sentence, and there's a lot of people that get confused between the two. So fundamentally, Kubernetes is about taking pods which contain containers which have applications in and deploying them at scale across a cloud network. Docker is the container solution itself. So the actual application itself is put into the Docker container. Because of this difference, Kubernetes is designed for auto-scaling, it's highly available, whereas Docker simply isn't, because it doesn't have to worry about that within the container itself. The Kubernetes environment will check for liveness and readiness of the health of the entire infrastructure, whereas with Docker, it's just really going to check the services that are coming in and out of the actual application itself within the container. Kubernetes is complicated to set up. It really is just simply complicated to set up, and what you'll find is a lot of cloud services will actually do the setup for you, whereas Docker is very easy to set up. As you would expect with the tolerance ratio, there is high fault tolerance with Kubernetes, whereas with Docker is low fault tolerance. Again, this is fundamental in the two different types of strategy that Kubernetes and Docker have. They're both connected tightly with each other, but they both do different things. So what are the notable features of Kubernetes? One is the ability to do container balance. Kubernetes always knows where to place a container within its entire network, within the pods and with its infrastructure. The services are managed for security, network, and storage. It is self-monitoring, so it goes in and is able to check its own nodes for health and the containers within the nodes, so it makes sure that the applications are always running effectively. You can do the scaling effectively, both vertically and horizontally within Kubernetes. The solution is open source, so there's no actual fee for the actual Kubernetes service itself. And Kubernetes allows for storage orchestration. What does it mean by storage orchestration? Storage orchestration is that you're able to access and share either local storage, such as a hard drive or SSD drive, or a cloud-based drive. And my preference is always to go with cloud-based drive, because then you're really positioning your solution to be a true cloud-based application. So what are the main advantages of Kubernetes? Well, you get automatic rollback for changes that go wrong. You're able to automate a lot of the processes that would have been manual processes previously. You're able to scale the resources both vertically and horizontally easily and quickly. And then these three areas, the rollback, automating services, and being able to scale, indirectly allows you to save money by reducing the amount of time and people working on your operations environment. So let's break out the architecture of Kubernetes. So you're going to be asked to explain how is Kubernetes architecture structured. And there are three key areas. There's the application layer, there's the Kubernetes layer, and then there's the infrastructure layer. We're going to start off with the infrastructure layer. And so the infrastructure layer is our base layer, and this is where you make your clusters for your collections of storage and networking resources within Kubernetes. And this is where you would have, if your databases are your data stored locally on a hard drive or in the cloud, your core network and the VMs that you'd be building out your infrastructure on. These allow you to group many machines together into a single unit so that you're able to scale up and down very easily to meet customer demand. So let's talk about the middle layer, which is the Kubernetes layer now. So if we're looking at our architecture for our Kubernetes layer, it's really broken down for the core operating system, the Docker container environment, and the Kubernetes code itself. And this is where you're able to take machines and pull them together as a cluster so that they work within that Kubernetes system. You have a master controller within Kubernetes that actually then will go ahead and manage the scheduler, the control manager, the API server. And then you'll be able to cluster all of these Kubernetes together so that they're all working and processing as one single unit. And then finally, let's look at the application layer where you actually have your apps. And so the application layer, where you have your pool and your services, Kubernetes will use API to connect in and out of this layer. It's to run your applications within containers, and you use instructions that are written in YAML or JSON to actually set up those containers. And you actually have the environment running on a plan that examines these instructions so it keeps the entire environment healthy. API ecosystem is used to interact with the cluster. So you don't have to do that by yourself. So make sure that you're referencing that the APIs are secured and connecting in and out of the system. And so you have your scheduler and control manager actually from the Kubernetes environment doing the hard work, and then the workers themselves execute the commands that are coming from Kubernetes. So you will be asked to kind of dig into some of the key areas, such as explaining the master node and listing its components. So the master node is comprised of 4 key components. There's the cluster store, the controller manager, the scheduler, and the API server. So 4 key components. Remember, 4 fingers, 4 components. And then you're going to be asked to maybe dig deeper into what is a cluster within Kubernetes. And so a cluster is really a combination of resources such as machines into a single node. And then those nodes are pulled together and work as a single cluster as a whole. Kubernetes will work with that whole cluster. And then once you're actually working with that whole cluster, if a node fails or needs to be removed, Kubernetes is able to do that quickly and effectively. So let's talk a little bit about what are the different types of controllers in Kubernetes. And there are 5 types of control manager. You have the node controller, the service account, the token controller, the endpoint controller, and the replication controller. And so the node controller controls and handles the node in the system. The service account enables access controls in the system. The token controller cleans up any tokens for non-existent service accounts. The endpoint controller joins services in pods to the endpoint objects, and the replication controller manages the pod lifecycle. So what is the role of the cloud controller manager within this environment? And so the role of the cloud control manager is really to help manage persistent storage. And so persistent storage is storage that's either local storage to the physical machine, such as an SSD or hard drive, or cloud-based storage. And this allows the storage to be shared across the entire network. What is the role of the Kube API server and the Kube scheduler? So the Kube API server is responsible for the establishment of communication between the Kubernetes nodes and the master components, and it does this through APIs. The APIs themselves are all commands that are REST-based commands, and it implements an interface, which means different tools and libraries can communicate effectively with each other. So what is the role of the Kube API server and the Kube scheduler? So the Kube scheduler actually does the distribution of work across the entire infrastructure. So the actual YAML scripts that you've written are executed appropriately at the right time. So you're going to be asked to explain persistent volumes in Kubernetes. So a persistent volume is just a place where you can store data. Again, this can be local data, as in a hard drive local to the physical machine, or it can be cloud-based data. So what is a kubelet and a kube proxy? So a kubelet is a service responsible for conveying information to and from the control plane itself. The process, the kube proxy itself is responsible for maintaining the work and the status within the node server. In addition, every node in the cluster runs a simple network proxy, and kube proxy routes requests to the correct container in that node. In addition, you'll have some basic and primitive load balancing and management of the node from the proxy itself. There's additional layers of management that get done outside of the proxy, but the proxy is also there to help do some localized load management. So what is kubectl? So kubectl is your command line or terminal window interface that allows you to execute commands, and later in this video we'll actually go through some of those commands. etcd is the store that configures the details and essential values, such as key value pairs, that are distributed across your entire network. It also manages the network rules and the post-forwarding of activity. So what are the disadvantages of Kubernetes? Well, the first is it's really hard to install and configure, and this is why Azure and many cloud services such as Google Cloud will actually do the installation and configuration of Kubernetes for you. It does take a long time to get up and running with Kubernetes, not so much for the actual software, but your own experience of being able to use Kubernetes. It is not simple to manage the service. You actually have to have a lot of experience, and this is why people get paid a lot for Kubernetes skills. It's a difficult environment to get up and running and be effective in that management. Again, Kubernetes is just not an easy platform to learn. It takes a lot of time and effort. And one of the disadvantages is that while Kubernetes itself is free because it is an open source project, getting the people who are skilled to using Kubernetes is expensive. All right, so those were kind of the introductory questions that you can expect to be asked in your interview. The next set of questions are really going to be on an intermediate and advanced level, and these are the questions that will be thrown out. You know, you see these as being the trick questions, which are really there to test that you have the skill set to be able to implement and manage Kubernetes within a company. So what happens if a master node fails? What happens if a worker node fails? How would Kubernetes manage that? Well, Kubernetes is really designed for this kind of scenario, and so you can actually look at it, and the response would be is that the pod itself does not get affected. Kubernetes will actually respond and fix the failed node, whether it is needs to be repaired, whether it needs to be restarted, or needs to be replaced. So what is a service role in Kubernetes? So a service role is an abstraction for the pods. It provides a virtual IP address and allows clients to connect to containers running in the pods using that virtual IP address. And the command that you would use to get that, we would use some of these kubectl commands. It's quite a simple one. It's kubectl get services, and you get a full list then of all the services that are available. So how do I do a rollback in deployment? So there's a couple of ways you can do the rollback. The first is if you want to see the rollout history deployment, you would write kubectl rollout history deployment and then in square brackets deployment. If you want to just restore to the previous rollout, the command would be kubectl rollout undo deployment and then in square brackets deployment, and that would take you back to the previous deployment. So what is an ingress controller? So an ingress controller really is a pod that manages that inbound traffic, and a prominent feature of that traffic is that it is secured with an SSL termination. And so what we're going to do to now address some of the key ways in which you can provide API securities on Kubernetes, and we have 8 of those. The first 4 are implementing TLS for your security. The second would be API authentication. The third is to make the kubeless protection, the kubeless protected via authorization mode equals webhook command. The fourth is to monitor RBAC failures. The fifth is to remove those default service account permissions. 6 would be to filter egress to Cloud API metadata APIs. The 7th is to use pod security policy to restrict container policies and protect the node. And the 8th and final is to keep the kube at the latest version. All right, let's go into some of the more advanced commands. And so the advanced questions that you're going to get are all going to be commands that you're going to be asked to write. Now, my advice for you for these questions is to make sure that you have some of these basic commands memorized. They don't have to be perfect when you're in the interview environment, but it's good to be able to get up to a whiteboard and actually write out what these commands are, just so you can actually demonstrate that you know what the commands are. The interviewer isn't going to ask you questions on how would you apply Kubernetes to the company that you're being hired for, because you simply don't have that knowledge. But they do want to be able to see clearly that you understand the commands and terminal window instructions that will be able to demonstrate how you would actually go in and access some of that information. So one of the first questions you might be asked is, how do you package Kubernetes applications? And so you would use the package manager within Kubernetes to be able to manage and configure and deploy applications into your cluster. And so here we have the Helm command that you would use. So what are init containers? And an init container gets executed before any other containers can run on the pod. And so you want to be able to illustrate what the init instructions would look like. And here we have an example, and I would again use this example and maybe memorize it for when you have this question come up in your interview. So what is the difference between a config map and a secret? And these are more fundamental. So a config map just has the instructions that are clearly available in plain text on what the kube is supposed to do, whereas the secrets are actually encrypted, and these are like passwords and other sensitive data that you don't want to have easily available. These are encrypted information and have to be decrypted to access the content. So if a node is tainted, is there a way to schedule the pods to that node? And the answer is no, there isn't. And so what you have to do then is schedule the pod to be fixed, and so that schedule the pod to fix the tainted node to allow for tolerations to that. And we have here the example code that you would use to do that. So how do you deploy a feature with zero downtime in Kubernetes? Well, Kubernetes is designed to be able to roll out applications with zero downtime. And here we have 4 examples using the rolling update as a strategy for zero downtime deployments in Kubernetes. Again, memorize one of these so you can actually illustrate how you use rollout to be able to deploy a zero downtime solution. So how do you monitor a pod that is always running? And so to do that, you would use the liveness probe to check the health of the application within the pod and see whether or not there are any failures or whether or not the pod itself needs to be restarted. it. So how do you drain traffic from a pod during a maintenance? So again, this is a simple command for you to remember, but to be able to drain an application so that it's easy for you to be able to do maintenance on the application, you would use the kubectl drain and then in square brackets the node name, and that would then temporarily drain that particular pod so you can actually do maintenance on it. What you have to then, and this would probably give you bonus points if you're in an interview, is then reference the uncordon command so that you can uncordon the actual node itself so that the pod itself can come back up into live and work as a fully functioning solution. So to be able to tie services to a pod or to a set of pods is that you can apply labels to the actual pods themselves and then use the labels as selectors to be able to glue services to that pod. And again, we have here an example of how you'd actually do that. And again, this is one of those where you probably won't be asked to write this out, but it'd be good to have this memorized. How do you get all pods on a node? And so the following command will actually go ahead and bring all the pods into a Kubernetes cluster. This is quite lengthy, and maybe you want to talk to how this would be done. But we have the instructions on how to do that right here. The important part is to make sure that you, when you're talking about the node name, that you reference to whoever you're interviewing what you would switch out to reference the actual nodes that you're trying to pull together into the Kubernetes cluster. So how do pods mount NFS volumes? And so in these examples here, we actually define the NFS server and then the pod and how you'd actually mount two together. Again, what you want to be able to do is illustrate why you would use YAML and how you'd actually then point to specific IP addresses within your Kubernetes environment, within either the production or test environments, to be able to illustrate how you would mount up those NFS volumes.
And with that, we have reached the end of day 2. So far, we have learned the Dockers and Kubernetes. On day 3 of DevOps Learning Week, we will reveal the next stage where you will master the DevOps testing. So, stay tuned and don't miss it out. Thanks for watching, don't forget to subscribe and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.